Hi everybody, my name is Karupa, and in this short video, I'm going to walk you through configuring your machine to start building Apache Cordova apps. Now, if you want to take care of configuring your machine manually, you have a lot of work ahead of you. You need to install a bunch of dependencies like Node, Chrome, the command line tools, Java, and others. And installing dependencies is only one part of the equation. You also need to configure them and make sure they all work properly together. That often involves modifying command line targets, setting environment variables, and ensuring your deployment works across not just devices and emulators, but also the web server if you're dealing with browser-based scenarios. Now, I don't know about you, but it's a lot of work, especially work that I'm not very familiar with. And fortunately, if you're using Visual Studio 2015 to build Apache Cordova apps, we greatly simplify all this for you. In Visual Studio, we give you a unified installer that not only gives you all of the Visual Studio components, but you also get the ability to install third-party components as well. The way to take advantage of this is pretty easy. During installation, go to the optional install screen and check the box for tools for Apache Cordova. Once you check this box, we take care of ensuring we download the dependencies, configure them, and make sure they work properly for your specified configuration. And after installation is complete, you're ready to start building Apache Cordova apps. So if you haven't done so already, go ahead and download Visual Studio by going to aka.ms/Cordova. And during installation, if you run into any issues, we'd be happy to help you out. Post on Stack Overflow, use the hashtag Visual Studio Cordova, or also tweet to us on Twitter at VSCordova Tools. And with that, I will see you guys next time. Hi everybody, my name is Karupa. In this short video, we're going to dive right into building our very first Apache Cordova app. So first, go ahead and launch Visual Studio. Once Visual Studio launches, you'll see a start screen. You'll see a lot of helpful links and news about what's going on in the Visual Studio community. But what we want to do is create a new project. So go ahead and click on the new project link from the start page, go to File, New, and select the project link from the menu bar. Once you select New Project, the New Project dialog will appear. And this dialog gives you an overview of all the various projects that you can create as part of your Visual Studio installation. What we want to create are Apache Cordova apps. So find the JavaScript node or the TypeScript node, and under it find the subnode called Apache Cordova apps. And once you've selected the Apache Cordova apps category, you'll see the templates that we currently provide for allowing you to build your first project. And I'm going to keep it simple. I'm going to select a blank application template, and let me go and give it a name. Let me call this one Hello World Channel 9. And once I've given my project a name, I'm just going to go ahead and create it by clicking the OK button. Once you click OK, Visual Studio will take a few seconds to go ahead and get your project created. You'll see a start page that gives you additional information on where your next steps can be. And in your Solution Explorer, which is the tree view on the right-hand side, you'll get an overview of what your files and folders that make up your project currently are. And these files and folders mimic the exact structure of the pages you would see if you were to build a Cordova project not using Visual Studio, but using any of the third-party tools available. So what we want to do is go ahead and just build a simple Hello World app. So I'm going to go ahead and open the www folder and open index.html. And when I open index.html, you'll see the primary view in Visual Studio switch to the code editor, which in this case is color formatted and optimized for displaying HTML content. And notice we have a p tag in our HTML page, and it says, hello, your application is ready. And what we're going to do is modify this to say, hello and world. I'm going to go and type it in directly inside it, if I can spell it correctly. And let me go ahead and preview what my changes are. Now to preview your application, there's an area we call the F5 debug toolbar. This is an area you'll be spending a lot of your time on, because this is what controls for what platform and what deploy target you'll be building your app against. In this case, I'm going to keep it at the default, which is Android, and Ripple, the browser-based simulator, just to quickly make sure my application works properly. And once I'm ready, I'm going to hit the green button to go ahead and preview it. So when I hit preview, behind the scenes, we do a lot of work to not only build a package, but also get everything ready to run my application. So in this case, because Ripple is a browser-based simulator, you see it running in Chrome, and then you see the words Hello World displayed. So there you have it, a very, very quick overview of how to build an app using Apache Cordova in Visual Studio. If you haven't downloaded Visual Studio yet, go to aka.ms/Cordova. And if you run into any issues along the way, we'd love to help you out. Post on Stack Overflow, use the tag Visual Studio Cordova, or tweet to us at VS Cordova Tools. And with that, I will see you guys next time. Hi everybody, I don't know about you, but I don't write perfect code. Maybe you don't either. And for those of us who don't write perfect code, we have a lot of tools in Visual Studio to help you to preview and debug your app to make sure your apps look great. So, as you know, a large part of your time will be spent ensuring your application looks and behaves as expected. And in Visual Studio, we give you 3 classes of debug targets you can use to test your app against to make sure your apps do function the way you intend them to do. You have Ripple, which is the browser-based simulator that you saw earlier as part of our Hello World demo. You have emulators and simulators for all the platforms, for iOS, Android, and Windows. And you also have physical devices. In this video, I'm going to take a simple application and show you how to both preview as well as debug them across all 3 classes of debug targets. So let's get started. I'm in Visual Studio now, and I have an application that I've already created to help demonstrate how to preview your code. So to preview your application, you have the F5 debug toolbar, which takes up the top part of the screen right here. And in this area is a centralized location where you can choose a platform you want to test your application against. For example, right now we support Android, iOS, Windows Phone, Universal projects, as well as multiple sub-flavors of that. And depending on which platform you select, you can also target either a device, an emulator, or a simulator in the case of Ripple. So for now, let's start with Ripple, since you've already seen it before. And it's also a great way to very quickly get into the swing of being able to preview and debug your application. So I selected Ripple, and I'm choosing a Nexus S device. And let me hit the play button to go ahead and test my application on it. Because Ripple is a browser-based simulator, it runs in the browser, Chrome in this case. And in a few seconds, you'll see your application appear. And our application, like I described earlier, is a simple random color generator. There's a button called Change Color, and I'm going to click it, and each time I click the button, the color of our background changes. And what Ripple provides, in addition to being able to just run your application, is also simulate device capabilities. There's a lot of UI and Chrome around it that allows you to change, for example, the orientation, or change the accelerometer settings, or network capabilities, and various other settings that you'd find important as part of testing your app on an actual device, when an actual device or even emulator isn't readily available. Now, previewing your application is just one part of what Visual Studio allows you to do. We actually provide great debugging capabilities as well. So right now I have index.js open. I'm just going to arbitrarily pick a file that I want to debug and check what line is going to happen when the code hits. So I set a breakpoint on this code right here where the background color is actually being hit. And let me test on Ripple one more time. And the application launches. This time around, when I click on the Generate Color button, notice what's going to happen. Let's wait for the load. So I click on Change Color, and this time when I click on it, because I set a breakpoint in Visual Studio on the line of code that gets hit, my application removes myself from preview mode and goes into debug mode, where I can now walk through the code by stepping into, stepping out, all the functionality you would expect from a great debugger. I can also hover over the elements and see a tooltip for inspecting the objects and the properties under it. And you also have a console as well as various windows to allow me to more deeply analyze the objects that I'm currently dealing with. So that was Ripple. And Ripple is a very convenient way to quickly test your application in the browser. But let's go one step further. Let's look at one level of fidelity deeper, where we want to run our application on an emulator itself. In this case, I'm going to use the iOS simulator instead. So I'm going to go to the debug dropdown. I'm going to choose iOS, and I'm going to choose simulator iPhone 6. Now, to preview for iOS, there's one extra step that we need to follow. We need to configure a remote build agent, which allows you to listen for changes on your project and ensure the Mac side of your application is built and deployed properly. So for this, I'm running Parallels, so I'm going to go back into my command prompt. And the command I'm going to use is vsmda remote, and let's quickly look at what the full commands for that look like. So in order to test for iOS devices, you install the vsmda tools, and that's an npm package you can very easily install using the command I've shown here. And to run the MDA remote tools, which is a build agent that listens for file changes and builds your application, you just type in vsmda remote. Our documentation goes into much greater detail, so I'm not going to go into much further detail than that. But in the terminal window, I currently already started vsmda remote, and it's currently running and listening for changes on the Visual Studio side. All I need to do next is make sure that when I go into Visual Studio, it is aware of the build agent and how to access it. And the way you do this is by going to Tools, Options, finding the Tools for Apache Cordova node, and selecting the Remote Agent Configuration screen. Here you can specify the path to let Visual Studio know about the remote agent and how to actually communicate with it to build my iOS project. I've already pre-configured it for you, so I'm going to go ahead and hit OK. And now let's go ahead and hit play to make sure the application works properly on an iOS device. And I'm going to remove the breakpoint because I don't feel like debugging it just yet. So I'm going to hit play, and let me switch over to the Mac side. And as my project is being built, you'll see that the log output clearly indicates that the project has been detected and a build file is being generated that's going to be deployed to the iOS simulator. And as you can see right now, you can see the same application you saw earlier now running on the iOS simulator. Let me click on the Change Color button again. As expected, as I click on it, the background color changes. Great. So the last thing we're going to do is we looked at Ripple, we looked at emulators, and now we're going to look at the ultimate way of ensuring your application works properly, running it on a device where not only does it look as you would expect, but also the performance characteristics more closely mimic what your customers would see when they're running your application. So I'm going to switch the debug target from iOS to Android, and I'm going to select Device. And on my desk here, I actually have a Nexus device that is currently set up. So I'm going to hit play, and in a few moments, the same project you saw earlier will now get deployed to the device I'm currently holding on my screen. And this will take a few seconds. All right, you can see now that the application is launching, and the same app that you saw earlier is now displayed. The Change Color button displayed in the top left corner. So I'm going to go ahead and click it, and let's see the background color changing. All right, and I can keep clicking it, and the background color changes. And the thing to note, which I'm not showing in the video yet, is if I had a breakpoint set in my code, I can also debug my code even if the application is running on an actual device, which is really cool. All right, so you just saw how to test your application on Ripple, on an emulator, as well as on a physical device. And if you haven't had a chance to play with our tools yet, go ahead and download them from aka.ms/Cordova. And if you have any questions along the way, feel free to ping us on Stack Overflow, use the Visual Studio Cordova tag, or tweet to us on Twitter at VSCordovaTools. And with that, I will see you guys next time. Hi everybody. As web developers, we have a rich variety of tools we use to often help us build our application. In this short video, I'm going to show you how Visual Studio helps you interoperate with those tools. So in Visual Studio 2015, we've done a lot of work to ensure that projects you create are compatible with third-party tools, namely CLIs such as Cordova, Ionic, and more. And I'm going to give you a quick demo that shows you how to round trip between Ionic and Visual Studio to build a very simple application. All right, let's take a look at all the steps required. So I have Visual Studio open right now, but what I'm going to do though is create a project not in Visual Studio, but I'm going to use the command line tools that Ionic provides. So I'm going to go to Start and bring up the command prompt. And let me navigate to my desktop and create a new project that is going to be using Ionic's functionality. I'm going to use Ionic, start. Let's call this application My Ionic App. And let's use a slide template that gives you a starting point, that gives you some interesting sliding functionality. So hit enter, and right now you'll see that Ionic is doing its thing to help create the project. And if I go to the desktop, you'll see that the same project has been created. You'll see My Ionic App and the various files and folders needed to help build my application. Now what I want to do is open this exact same project in Visual Studio. As you know, in Visual Studio, you have what are known as project files. These are files that give you some idea of what files and folders this particular solution will be using. And things are no different if I want to open this project in Visual Studio as well. What I'm going to do is add two files to my project, a JSproj, as well as a JSON file that gives me some basic metadata about the project that Visual Studio will be dealing with. I've already copied it, so I'm going to paste it into my project right now. The file is the JSproj named CLI, and a JSON file is named Tools for Apache Cordova. So let me now go into Visual Studio, and this time I'll open the project that was just created by Ionic. I'm going to navigate to the My Ionic App folder and open the CLI project. And notice that as the project is opened, the exact same file folder structure you saw earlier as created by Ionic is also shown right here for me. Now, I'm not done yet. What I'm going to do, though, is make some more modifications to this project in Ionic. So what I'm going to do is add a platform for Android so that my application is ready for being able to build for the Android platform. So I'm going to go back into Ionic. Let me navigate to the directory my project is created in, which is My Ionic App. And let me just go ahead and use the platform command to add a platform for Android. So Ionic platform add Android. And once I hit enter, pay attention to what you'll see in the Solution Explorer in Visual Studio. I hit enter, and notice that as I've created projects being created, you see the platforms directory being created for you and populating with all the various contents that Ionic is going to add to ensure that my project builds properly for the Android platform. And I can now, from here, I can continue to make changes to my project either in Visual Studio or I can make them in Ionic, and the round tripping just works beautifully. You can try this out on your own. Go to aka.ms/Cordova to download the tools. And if you have any questions, post on Stack Overflow, use the tag Visual Studio Cordova, or tweet to us at VSCordovaTools. And with that, I will see you guys next time. Hi everybody. One of the things that sets apart Apache Cordova apps from web apps is Apache Cordova apps can access native device capabilities. And that access is handled by something known as plugins. So plugins are what allow your app's JavaScript to access these capabilities. And these capabilities include your battery, your camera, your geolocation, your media access APIs, being able to access your contacts, and a whole lot more. And in this video, I'm going to show you a quick overview of how you can use Visual Studio to take advantage of plugins to add device capabilities to a very simple application. So let's take a look at that. So I'm in Visual Studio right now, and I have a simple application that I've already created. And this application requires the accelerometer to change background color depending on how rapidly I am moving the device around. So what I'm going to do first is I need to add a plugin. To add a plugin, we have the config manager, which is a centralized location where you can not only view all the plugins that are currently available, you can also view which plugins you've currently added to your project, and you can also add custom plugins that might not be available to your project out of the box. So the plugin I want to add is called Device Motion. So I'm going to select it. I'm going to click on the Add button. So while the plugin is being added, you'll see that we give you a lot of information about the plugin ID. In this case, it's an Apache Cordova plugin. We give a description, and also which platforms it's available on. And once the plugin has been added to my project, you'll see a green icon that indicates that this project currently supports the Device Motion plugin. And before I just run the application, let me just do a quick overview of the code itself so you have an idea of what is going on. The Apache Cordova documentation provides you with a lot of helpful tips on how to use various plugins. In this case, I copied this code directly from their site on where I'm accessing the accelerometer on the navigator object, and I just have some snippets of code that when the accelerometer detects rapid motion, it is going to change the background color of my application into some random color that gets returned by the getRandomColor function. So let's go ahead and test this application and see how it works. And to test this, I have a device right here I'm going to deploy my application to. So from the F5 debug toolbar, I'm going to go ahead and select device for my Android platform and hit play. And in a few moments, you'll see that the application gets deployed to the device. Okay, you'll now see that the application is getting launched. And what I'm going to do is, if everything worked fine, as I shake my device, the background color should change. Let's find out what happens. Yes, the background color is changing, and each time I shake it, provided it meets the threshold that I specified in the code for an acceleration to have happened, the device color will constantly keep changing. So if you want to try this out for yourself, download the tools from aka.ms/Cordova. And if you have any questions along the way, we'd be happy to help you out. Post on Stack Overflow, use the tag Visual Studio Cordova, or post on Twitter at VSCordovaTools. And with that, I will see you all next time. Hi everyone. Like any actively maintained open source project, new releases of Apache Cordova are released quite frequently. And as you're building Apache Cordova apps, you may want to target a newer version. You may even want to go back to an older version to be in sync with what your dev team will be working on. Regardless of your reason, using Visual Studio will make it very easy for you to specify which version of Cordova you want to use to build your project. So let's take a quick look at how to change your versions. I'm in Visual Studio right now, and what I'm going to do is create a new project. I'm going to go to File, New Project, and I'm going to specify a JavaScript-based Apache Cordova app. Let's give it a simple name, version. And when your project is getting created, by default, we don't download any of the Cordova binaries for you upon project creation. It's very much a build task, and you'll see why. I'm going to open config.xml and go to our config designer. And I'm going to go to the Platforms directory. In the Platforms directory, you'll find that there's a property called Cordova CLI. And here you can specify the version number of the Cordova platform you want to target, or a URL to a Git repository where a custom version of Cordova might live. And depending on what version you specify, when you do a build by going to Project, by going to Build, and then Build Solution, at this point, we take the version of Cordova you specified here, or a CLI URI, and we build a project using that particular version. And with this, you can ensure that Visual Studio, as it is right now, uses the version of Cordova that you've targeted, and you can change these very easily as you need to. All right, that was a very quick look at how to change your Cordova version that your current project is built against. If you want to try this all out for yourself, go to aka.ms/Cordova, where you can download our tools. And if you have any questions, post on Stack Overflow, use the tag Visual Studio Cordova, or tweet to us at vscordovatools.com. We'd love to hear from you. And with that, I will talk to you guys later. Hi everybody. A natural destination for the apps you build is on an app store. And in this short video, I'm going to talk about how to take your Android app and package it up to deploy to the Google Play Store. So in part of explaining this, I'm going to be throwing some words at you which may seem a little bizarre, a little arcane. So let me explain what they mean. So by default, the binaries that you build for Android are what are known as unsigned debug builds. They're unsigned in that the validity of who built them isn't verified. They're also debug in that there's metadata and content in these files that allows you to optimize for debugging your application and doing things that an end user might not want to do. So the solution is, in order to submit a package, which is an APK for short, to the Google Play Store, the binaries you create need to be both signed and built in release mode. And you'll see shortly what they all mean in this very quick demo I have on how to sign an Android package. So I'm in Visual Studio right now, and what I'm going to do first is just create a new project to show you what exactly is going on when a project gets built. I'm going to go to File, New Project, and let me create a new Apache Cordova app that's JavaScript based and just call this one Signing Demo. All right. So the first thing we're going to do while the project is getting created is in the debug toolbar, we've seen lots of examples of being able to change the platform and the target device or simulator or RPL you're trying to deploy to. What I'm going to do right now is change the solution configuration from debug to release. And without doing anything else, let me just point to a device. Let me build my application. And I do that by using the build menu's build solution command. And while the project is being built, let me go to the folders that get generated as a build is happening. So I have the current signing demo project open in Windows Explorer. And I'm going to go into bin, and let's go into the Android directory. Let's wait for the project to get built before I navigate further. And we'll take a look at the contents that you'll see inside there. All right, you see a notice now that says build succeeded. So let me now go to my bin directory. Let me go to Android, release. And you'll see a bunch of files that are created. The ones that are most interesting are the ones with the APK file extension. Notice right here I have Cordova app-release-unsigned. So the release flag comes in because I actually built for a release configuration. The unsigned part is what I want to fix next. To sign a file, the way Cordova does it is in your res native Android folder, you have an ant.properties file. This file specifies the location of the key you want to sign your project in, as well as some other information like the alias and the password needed. To help specify the key and other properties needed to properly sign our package, I'm going to be using a tool called KeyTool that Google releases as part of the Java development kit. So in an administrator command prompt, which I've already opened, navigate to the directory your JDK is installed. By default, Visual Studio installs it to your program files x86 directory, Java, and then a JDK directory that corresponds to the version of the JDK you're using. In this case, I'm in 1.70. And in the bin directory, there's a tool called KeyTool. And let me type it in. So this is the tool that basically takes all the arguments it needs to generate a key that validates that you are the person who is building and declaring this application ready for deployment. The arguments are fairly long, and you can find documentation for it. I've already copied it into memory, so I'm just going to paste it in here. And let's walk right through it. I specify the key tool. The important things to note are the key store value, which is the location on my disk where the key will be created, which in this case will be the C drive, and release.key is the file that will be generated. My alias is Krupa-C, and then some other properties that specify the type of security that will be used to sign the key. I'm going to hit enter now. And as part of hitting enter, the tool will ask a lot of questions that you'll need to fill in. For example, enter key store password. I'm going to type in PASSWORD. And I'm hoping your password will be more secure. And let me retype it again to validate that I remembered it. And now my first and last name. And there'll be a few more questions you need to make sure that you answer. I'm going to quickly go through these. Organization is Microsoft. City is Redmond. State is Washington. And the country is the US. And all this information looks good. Now, once I've created the key, you'll see that it'll ask for one more question about a password. The file will now be created in my C drive. Let me go there to make sure it looks right. There you go. You see release.key that is now showing up in my C drive. Now all that remains is for me to specify the values I created earlier into the ant.properties file that I showed you in Visual Studio. So the key.store is the location on disk of the actual key, in which case it is my C drive. I'm double slashing it to avoid any escape issues. Release.key. Let me make sure the name is correct. My alias was Krupa-C, and my password is PASSWORD. Yes, it is displayed in plain text in your project. And I'm going to save this file. And now let me build my application one more time. I'm going to go to Build, hit Build Solution. And while it's going on, let me go ahead and open the folder again and navigate to the release directory, where hopefully the signed binaries that are also in release mode will be available. and the project is still being built. So here, build has succeeded, and notice that now you have Cordova app-release.apk, and this is the package file that is both in release mode, and it also has been signed, because that -unsigned flag is no longer there as part of the name. And this is where you can submit to the Google Play Store to have an application that you can distribute to have other people use. All right, that was a quick look at how to sign a package for the Google Play Store. And if you want to download the tools to try it out for yourself, go to ak.ms/Cordova. And if you have any questions along the way, post on Stack Overflow, use the tag Visual Studio Cordova, or tweet to us at vscordovatools.com. And with that, I'll see you guys next time.
Are you an Android developer? Or are you looking to build your first Android app? This might surprise you, but Microsoft has a bunch of tools and services that make an Android developer's life a little bit easier. Whether you want to build the app using JavaScript and web standards, C#, or even C++ and Java. I'm Amanda Silver, and I'll show you how Visual Studio can make you a more productive Android developer. Visual Studio's easy setup gets your dev box ready fast. It's pre-installed with many project templates so you can get started building your app. It has integrated support for debugging across devices and emulators. We even have a Visual Studio emulator for Android, which is fast and can be used with other IDEs like Android Studio or Eclipse. Visual Studio Team Services supports continuous integration and deployment for Android apps, no matter how you've written them. And you can use Hockey App for your post-production needs, like distributing betas, analyzing crash reports, and getting feedback from your customers. Let me show you how. Visual Studio gets you going fast by setting up everything you need for Android development. Once set up, you can see that Visual Studio provides you with a variety of templates to get going. If you want to build your app using web standards, you can use the Apache Cordova app templates to iterate quickly using a workflow that's familiar to web developers. If you want to build your app using C#, the Xamarin extension for Visual Studio provides you with a variety of project templates and even support for Android Wear. You also get great IntelliSense for Android. You also get the world's best Android designer. If you're building using C++, you can build an app using OpenGL, a native activity, or just a shared library. If you're building using C++, Visual Studio has one of the fastest debuggers out there. New in the latest update, we even allow you to step into code for Android written in Java. Building your app with JavaScript, C# or C++ allows you to have maximal code sharing, which makes it easier to build with a common codebase when you're also targeting iOS. No matter which programming language you use, you'll find the Visual Studio emulator for Android super useful. Because it's x86 based, it's really fast to get started. It supports multi-touch, which is amazing when you're developing on a touch-enabled dev box like the Surface Book with Windows 10. The emulator is even available standalone and can be used from Android Studio or Eclipse. Today, we're announcing that it's coming soon to the Mac. Visual Studio Team Services allow you to build for Android using Gradle. And you can use Hockey App, now a part of Visual Studio Team Services, to deploy your app and gain insights into how it's performing in the wild, things like feedback and crash analytics, even into Java code. No matter how you're building your Android app, Visual Studio can make your team more productive and your life as a dev a little easier. Check out other videos that go deeper into some of the topics I discussed. Follow us on Twitter to stay current as we enable new functionality for mobile development, and watch the VS blog for best practices, testimonials, and tips and tricks.
Hi, I'm John Chemnitz, a program manager on the Visual Studio team, and I'll be giving you a brief introduction to our fast Visual Studio Emulator for Android, available as a free download from visualstudio.com or as part of Visual Studio 2015. Let's talk about 3 major challenges you have as an Android developer. First, you want to be able to rapidly iterate on your app. Next, you want to get your app working across the wide range of Android hardware available on the market. Finally, you want to be able to reproduce real-world scenarios without needing to reach for a physical device. First, let's talk about how you can debug and test your Android applications at lightning speed using our x86 Android emulator. It boots up faster than other emulators and runs at nearly the speed of a real device, even when debugging graphics and processor-intensive apps. It also runs side by side with the Windows Phone emulator and other Hyper-V VMs, making it easy to develop cross-platform applications without needing to continually toggle system settings. But to iterate rapidly, you need more than just a performant emulator. You also need it to work seamlessly with your favorite IDEs to help you debug and test your app. Let's start by looking at Android Studio. The emulator for Android is available as a free download from our website, so you can simply run the Visual Studio emulator for Android from your Start menu, hit the play button, and you're ready to connect from any Android IDE or tool. It is ADB connected, so it appears as a debug target directly in Android Studio. For an even better experience, check out Visual Studio 2015. With built-in support for Android development using C++, HTML, and JavaScript with tools for Apache Cordova, or C# with Xamarin, Visual Studio offers a great set of tools for cross-platform mobile development, and the emulator for Android is included when you install any of these project types. When you're ready to debug, the emulator is built right into your debug target menu, as you can see here in the C++ native activity project. Simply hit the play button, and the emulator will launch your application and start your debugging session. As an Android developer, you know that getting your Android app working on one screen size and version of Android is worlds away from getting your app working on every device you need it to run on. Testing your app against the range of API levels, screen sizes, and other hardware properties of Android devices in the market can be an expensive headache. We've curated a set of device profiles that represent the most popular hardware in the market, including devices from Samsung, Motorola, LG, and more. Let's take a look at how quickly you can get started testing your app everywhere. Using either the Tools menu in Visual Studio or the Start menu item, you can open our Emulator Manager, which lets you install and run device profiles that meet your needs. We have a range of form factors, screen sizes, and API levels to choose from, now including Android Marshmallow. You can install and get running with one of these in just 2 clicks. Hit the Install Profile button, and then hit Play once the profile is ready to go. Multiple profiles will even run side by side. Now that you're able to quickly validate your app across a range of devices, the next challenge is reproducing the real-world environments in which your app will run. What happens to your location-based newsfeed when the user is driving down a highway? How does your multiplayer OpenGL game react to slow or lossy mobile networks? Forget complicated, limiting command line controls. Our built-in simulations can put your app in any situation without leaving the comfort of your desk. Hit the arrow button in any device profile to open the Additional Tools window, where you can control various device simulations. Use an image or your PC's webcam to emulate the camera on the device. Drop a few pins and live journey across the map at real speed limits. Drag and drop an APK onto the emulator and it is quickly installed. And run graphics-intensive OpenGL apps with touch input from your multi-touch display. Many Android developers are also developing on the Mac, so wouldn't it be great if you could use this emulator there too? Today we are excited to share that we're working on bringing our emulator to Mac OS X and encourage you to visit our website to sign up to be the first to try it when it becomes available. The Visual Studio Emulator for Android makes developing your Android apps easier because it's fast, emulates a wide variety of Android hardware, and easily simulates real-world environments. And coming soon, you'll be able to use it on your PC or your Mac. Ready to get started? Use the link on my right to visit our website and download the Visual Studio Emulator for Android. Thanks for watching and have a great day.
Are you an iOS developer? Or potentially you're looking to build your first iOS app? Now this might surprise you, but Microsoft actually has a bunch of tools and services that can make a developer's life just a little bit easier, regardless whether you want to build the app using JavaScript and web standards, C#, or even C++. I'm Jonathan Carter, and in this video I will show you how Visual Studio can make you a more productive iOS developer. Visual Studio's easy setup gets your DevBox ready fast, including a handshake with a local or remote OS X box for build. It comes pre-installed with many project templates so that you can get started building your app fast. It also has integrated debugging support for both devices as well as remote simulators. Visual Studio Team Services supports continuous integration and deployments for iOS apps no matter how you've built them, even if you're using Xcode. And you can use HockeyApp for your post-production needs, like distributing betas, analyzing crash reports, and getting feedback from your customers. Let me show you how all of this works. Visual Studio gets you going fast by setting up your DevBox with everything you need for iOS development. With a simple handshake, you can set up a local or remote Mac machine for building your iOS apps. Once set up, you can see that Visual Studio provides you with a variety of templates to get started building your iOS app. If you want to build your app using web standards, you can choose one of the Apache Cordova app templates using either JavaScript or TypeScript. You can iterate quickly using a workflow that is even familiar to web developers. If you want to build your app using C#, the Xamarin extension for Visual Studio provides you with a variety of project templates, including traditional UIKit apps, OpenGL, SpriteKit, and even Apple Watch extensions. Once you've created your project and are beginning to write some code, you'll even notice that directly within Visual Studio, you get a great IntelliSense experience even for the iOS APIs. You can even connect to the storyboard design surface to build the visual components of your app directly in Visual Studio. If you're building using C++, Visual Studio also has project templates for iOS to help you get started building static or shared libraries. Building your app with JavaScript, C# or C++ allows you to achieve maximum code sharing, which makes it easy to build with a common code base to target not just iOS, but also Android as well. Visual Studio Team Services comes pre-built with support for iOS applications, which allows you to automatically build your Xcode projects as part of your CI server. You can also use HockeyApp, now part of Visual Studio Team Services, to automatically deploy your app to testers, as well as to gain insights into the health of your application using crash reporting. So as we saw in the demo, no matter how you're building your iOS app, Visual Studio can make your team more productive and your life as a dev a little easier. To learn more, check out the other videos that go deeper into some of the topics that I've discussed. Additionally, you can follow us on Twitter and watch the VS blog in order to stay current with new functionality that we enable for mobile development, as well as best practices and tips. Thanks for watching.
Hi, my name is Ryan J. Salva, and I'm one of the many program managers responsible for delivering Visual Studio 2015. Today, I want to share some of the new features available in this release, features introduced specifically to help developers like you build mobile apps for iOS, Android, and Windows using web technologies. Now, if you're not already familiar with Apache Cordova, it's an open source framework that enables developers to build packaged apps for mobile devices using HTML, CSS, and JavaScript. And unlike web apps, packaged apps give you access to native device capabilities like the camera or file system, support for offline scenarios, and the opportunity for monetization in the app stores. They also solve an important discoverability problem as more and more consumers choose to engage with apps on their mobile devices rather than the browser. Now, since we first announced Visual Studio support for Apache Cordova at TechEd in June, thousands of developers have used these tools to build packaged apps for iOS, Android, and Windows. And today I'm excited to announce we're releasing an update to the extension for Visual Studio 2013 and incorporating the same features into the Visual Studio 2015 release. No matter which version of the tools you install, as an extension to Visual Studio 2013 or included with Visual Studio 2015, the developer experience will be nearly identical, starting with installation. If you've ever done cross-platform development, you know that compilation for each platform requires a litany of open source and platform-specific components. Building for Android requires Ant, Java and the Android SDK. Deploying to an iOS device requires iTunes, and Windows requires the Windows SDK. After all is said and done, there are over a dozen toolchain dependencies that can take hours, even days, to properly download, install, and configure. Much more, some of these components update out of your control and require continued maintenance. Days of your life that could be spent solving real problems with code. Visual Studio will get you up and running quickly with a well-configured dev environment and help you stay that way. When you install our tools or open a Cordova project, Visual Studio performs an environmental diagnostic. If you're missing any dependencies or have somehow misconfigured an important link in the toolchain, Visual Studio will give you the option to fix the problem. Missing software? VS will download and install it. Misconfigured? VS will help you fix it. Once you're up and running, most of your time will be spent between the code editor and an emulator or a tethered device. To write code quickly and with fewer mistakes, developers have long relied on Visual Studio's IntelliSense for contextual help. Cordova is no different. Whether you're using JavaScript or TypeScript, you can depend on first-rate IntelliSense to guide you along the way. Let's take it on a spin. So, I've got a new blank Cordova project open here, and I want to build an application that takes advantage of the camera. This isn't something you could do with a normal web application, at least not without a tangle of browser-specific code. And Cordova abstracts away all the device-specific implementation into something called a Cordova plugin. Plugins provide a nice normalized JavaScript API so I can reliably access the camera across iOS, Android, and Windows using one syntax. I'm going to start by going to the config designer, which has been totally redesigned in this release, where I can find a list of core plugins vetted by Microsoft for compatibility with the most common in-market devices. Knowing that Microsoft has tested these plugins for compatibility is a huge confidence booster. And here, I find one for the camera. We're going to go ahead and add that guy in. Visual Studio tells me the version, the description, the platforms that it's compatible with. And if you look over here in the Solution Explorer, you'll see that Visual Studio has actually acquired the plugin and copied it locally to my project. All right, now that we've acquired the plugin, let's use it. Plugins like the camera use an asynchronous call to request data from the mobile device. I have some boilerplate code here that I'm going to copy and paste. Just apply to all. Excellent. And here, if we go into index.js, we'll see where some of that new code got added. Here, within the function where we invoke the plugin, you'll see navigator.camera.getPicture. That's the plugin itself. I'm going to invoke a similar method just by typing here, and you'll see that IntelliSense comes right up. .camera, there we go, .getPicture. As I move my mouse over that, I get an explanation of the method, its parameters, and how it can be used. If I'm using a popular framework, for example Angular or Bootstrap, I get similar IntelliSense for both JavaScript and HTML. Let's see how it works in iOS. For that, I'm going to deploy to the iOS simulator running on a Mac in my local network. As you can see, it's just come to the forefront, and here we are. Here's my application. Back in Visual Studio, the debugger is hooked up to the iOS simulator. The same would be true for a tethered iOS device, Android emulator, Windows Phone, whatever. No matter where I've deployed my app, I can use the same debugging tools to set breakpoints, inspect the DOM, and send commands via the console. To better understand how this works, I'm going to set a breakpoint. In fact, we'll do that right on the method where we invoke the camera plugin. And when I invoke that function by clicking on the Photo Library button, I can inspect the variable at my breakpoint and see exactly what value I've got in each of my variables and methods. Awesome. Of course, updates to Visual Studio don't tell the whole story. It's also about giving back. Through our partnership with the Apache Cordova community, we've contributed several updates to the framework in the last few months, including support for Windows 8.1 Universal projects, platform-specific configuration settings, and security updates benefiting all target platforms. We're working with an industry-wide community of contributors to ensure Apache Cordova is enterprise-ready. So that's about it for now. We covered only a fraction of the new features available for building multi-device apps with Apache Cordova, but you can already see that there's tremendous potential for developers, especially web developers who want to adapt their HTML and JavaScript skills to mobile app development. Compared to native application development, where you would have to develop the same app 3 times, once in Objective-C for iOS, then again in Java for Android, and again in C# for Windows, Cordova allows you to develop quickly and iteratively using well-understood web technologies. We hope you'll give it a try and send your feedback. You can find the product team on Twitter at VS Cordova Tools and download the product on visualstudio.com. Until next time, I'm Ryan J. Salvo with Visual Studio Tools for Apache Cordova. Happy coding, everyone.
To introduce myself, I'm Ankit Asthana, a program manager in the Visual C++ team. One of my focus areas is to work on cross-platform mobile development experience for Visual Studio. Today, specifically, I'm going to start with providing you a very short overview of cross-platform mobile development. I will also follow this up by highlighting the key capabilities that Visual C++ is going to provide to aid the cross-platform development story. I will also demonstrate these capabilities through the help of a short demo. Modern development today requires developers to provide their applications across multiple device platforms. From an application development perspective, C++ serves as a great choice as it allows developers to reuse their cross-platform code across a variety of device platforms, keeping the development costs low. Starting with Visual Studio 2015, Visual C++ will provide a great experience for cross-platform development. Using Visual C++ 2015, developers will be able to acquire all their cross-platform mobile development software easily and stay current with frequent updates. Visual C++ 2015 will also allow developers to build cross-platform mobile applications leveraging C++ for all major mobile platforms. In addition to this, Visual Studio Experience will also allow developers to share and reuse their cross-platform code easily, and top this by providing the fastest debugging experience for all these mobile platforms. With that said, let's now demonstrate these capabilities through a short demo. As a part of the File New Project menu, developers will now see the cross-platform node light up under Visual C++. With this node selected, developers can view a wide range of templates made available to them. Let's take a look at a few of them. The Dynamic Shared Library template will allow developers to create a dynamic shared library for the Android platform. This library will contain all the C++ code and can then be used to create an end-to-end application using Java or Xamarin. The other newly added Basic Application Android template allows developers to create an end-to-end application in Java. And the Makefile project template will allow developers to port over their source code easily from other IDEs as it leverages NDK build. Also notice the cross-platform templates, which are used to target and share cross-platform code between multiple platforms, including iOS, which we enabled recently. The last template that I want to talk about is the Native Activity template. Android with API Level 9 released the ability to create a complete end-to-end application in C++. This style of application is popular with game engines and other game-like things. Let's further explore this template type by looking at an example. So here I have the OpenGL example solution. It has two projects. The native activity project contains all the C++ code. Let us further explore the project by taking a look at the project properties. Project properties allow users to view, edit, modify important project characteristics. For example, using the target API level project property, developers can set the API level that they want to target for their application. Using the platform toolset property, developers can choose the platform toolset that they want to choose for building their application. We currently support both Clang and GCC toolchains. The last property that I want to talk about here is the configuration type project property. This property allows developers to choose what kind of application they're building. In this case, we're building a dynamic shared library or an SO file. Let's now hit cancel and take a look at the other project. The packaging project is used to take the existing dynamic shared library and create an end-to-end Android application using the Ant build system. For the next part of the demo, I want to bring up some source code to demonstrate the feature capabilities. For doing so, I'm going to bring up the main.cpp source file and traverse to the Android_main function. Android_main function is a characteristic function for native activity application type and acts as an entry point. As I play around in this function, notice some of the code authoring features that we've introduced. For example, the Android specific IntelliSense experience lighting up here as I choose the Android LogPrint API. Other features for code editing and authoring, such as code navigation, work well as well. To demonstrate this, take a look at the peak definition feature in action here. All in all, we've ported most of our code authoring features from the Windows experience and extended them for the Android platform as well. This will provide you a good code editing experience when developing inside Visual Studio. For the next part of the demo, I want to go ahead and show you the debugger capabilities. For doing so, I want to set a bunch of breakpoints. Notice the drop-down debugger menu is already populated with the fast x86 Microsoft Android emulator. This emulator is already running in the background. So I'm just going to go ahead and hit F5. On hitting F5, my application is built and then deployed onto the emulator. Notice the breakpoint that I set was hit. Also notice the debugger windows such as the auto window, the locals window, the threads window, and other debugger windows such as the call stack all light up nicely as well. As I mentioned, the Android debugger inside of Visual Studio that we've developed is the fastest debugger on the Windows platform when debugging Android code. To demonstrate this, notice as I actually move between different breakpoints. Furthermore, using this debugger experience, developers can also pass commands directly to GDB using the command window. For example, in this case, I'm viewing the backtrace for my application that's currently running using GDB exec. Next, I'm going to hit continue and let the app run. This app is a basic OpenGL app and it responds to user touch by changing screen color. Notice that happening as I click on the emulator screen. The emulator itself also has other capabilities. For example, you can rotate the screen and view how your application actually operates. I'm going to hit continue again because my debugger breakpoints were hit. or you can also leverage other sensors that the debugger actually provides. We currently support the accelerometer sensor, the location sensor, the network sensor, and so on. All in all, this is our development experience for Android when using Visual C++. In the next part of this demo, I'm going to show you how to debug a pre-existing Android application package file that you built in another IDE. For doing so, bring up the File New Project menu and choose the Dynamic Shared Library application type. I'm going to name this project Debug Pre-Existing Big Maps APK and click OK. On doing so, this creates the Debug Pre-Existing Big Maps APK project type. Choose the configuration that you want to debug for and hit Build. Next, bring up the debugger property pages and fill in the following information. This information includes the package to launch, which is the path to the APK, the package name itself, which can be found in the Android manifest.xml, the launch activity, which can also be found in the Android manifest, and last, the symbol search path, which contains the symbols for your application type. Click OK. The next thing we need to do is bring some source from the Big Maps application so that we can debug it into Visual Studio. For doing so, I'm going to bring up the map network manager.cpp source file into VS. Since we will be using this project only for deploying this application and not building, I'm going to uncheck Build in Configuration Manager and click Deploy. I'm going to set a breakpoint in this begin get URL function, which gets called during the Big Maps initialization. At this point, I'm ready to debug my Big Maps APK using Visual Studio. All I need to do now is hit F5. Notice that this application is getting deployed to your device. The Big Maps APK is pretty large in size, and the symbol search path contains over 500 MB of debug information, which is currently getting loaded, as you can see from the loading symbols. Notice that the breakpoint that I set was hit, and the autos and the locals window all light up nicely as well. Using this experience, developers can use the Visual Studio Debugger for their pre-existing Android application package files without moving completely into Visual Studio. Thanks for watching this video. To learn more about cross-platform mobile development, follow us on visualstudio.com or VCblog.
Hi, I'm James Montemagno, Developer Evangelist at Xamarin, and today I'm going to show you how to leverage your C# and .NET skills to build native iOS, Android, and Windows applications with Xamarin and Visual Studio 2015. First, we'll take a look at the entire Xamarin platform and everything Xamarin has to offer. And we'll see just how to build out those native iOS and Android apps all in C# inside of Visual Studio 2015. And also we'll take a look at some popular code sharing strategies to leverage 50, 60, 70% more of code across all platforms. And of course, I'll show you just where to get started. Now the Xamarin platform is what you'll be using to build and craft beautiful native iOS, Android, and Windows applications and sharing code across all those great platforms inside of Visual Studio. Now, our approach to mobile development is extremely unique. We enable you to build and a shared C# backend for your mobile applications, all your business logic, models, view models, RESTful service calls, SQL databases, things that are common across all the platforms. And then we give you the tools inside of Visual Studio to craft great native experiences and user interfaces for iOS, Android, and Windows, and access all of the native APIs. Now, if you're a Windows developer today, the .NET libraries are going to look very familiar to you. System data, link, XML, things that we know and love as .NET developers. And when you go to a new Windows platform, phone, store, desktop, you get some platform-specific APIs to mess around with, like phone or storage. And you can think of it the same when you use Xamarin to build out iOS and Android apps. You still get all of the .NET goodness, such as data and link and XML, but we give you 100% API access on both iOS and Android for all of the APIs. And then you get to take advantage of C# features like link, async await, lambdas, delegates, events, things that we know as C# .NET developers. And of course, we do the same thing over on Android, but with the Android APIs. Now, we have great tooling inside of Visual Studio to get you up and running with our iOS designer for Visual Studio to craft great iOS user interfaces, and of course, our Android designer built right into Visual Studio 2015. Now, when you install 2015 for the very first time, it's super simple to get started with Xamarin. Simply select the custom install option, and that will bring you to this next screen, and under cross-platform mobile development, you'll see Xamarin. Simply install Xamarin as part of your installation, and we'll take care of the rest. Now, if you already had Visual Studio 2015 installed, simply head over to xamarin.com/download for our universal installer, and we'll take care of everything for you to get you up and running building those cross-platform mobile apps. Let's take a look at just how easy it is to get up and running inside of Visual Studio 2015 with Xamarin to build native iOS, Android, and Windows apps all in C#. Here I am inside of Visual Studio 2015. Now, I've already created my project, but if you want to get started, simply select File, New Project, and this will bring up the project dialog. When you have Xamarin installed, you'll see Android and iOS project templates for a blank Android app, Android Wear application, even a WebView or OpenGL app. And under iOS, you'll find Apple Watch, other extensions, and of course iPad and iPhone applications to get you up and running building a single iOS or Android app. But to start to build a cross-platform mobile app, under Mobile Apps, you'll find blank applications with either a portable class library or shared project. Now, I've selected a blank app, native portable, and named it New App. Now we'll see in our project dialog, we have a blank new application with our shared code in our portable class library, an Android application, an iOS application, and a Windows Phone application, all referencing the same shared code. Now at this point in iOS, I can go in to my Add References, go to any of my assemblies, and bring in popular libraries that I know and love, like system.json, system.http, or system service model. Now I've selected and double tapped on main.storyboard. Our storyboard is an overview of our entire application. And this is where you'll be creating your native iOS user interfaces inside of Visual Studio with our iOS designer for Visual Studio. Here you have a full toolbox available for you with every single native control in iOS. So if you wanted to bring in a switch, just go ahead and bring it over, drag and drop it on. Here I have a button. And every time I click this button, I want to just simply increase the count. I can come down to my property window, come down, maybe rename this and say click me, and we'll see the designer update in real time. If I want to add a click event, simply double click. And now we've added a click handler right in our code behind of our UI view controller. I have a little bit of code here, a little public integer with a get set. We'll set it using some C#6 properties, and then I'll create a method called increase count. Now instead of using a string format, we'll use a brand new C#6 syntax, and we'll say you clicked this many of times. There we go. And of course, we'll want to increase our count ahead of time. Now in our click handler, we can say button, click, set title, and we'll simply pass in the string. Say increase count, for the normal state. So now whenever we click That button will increase the count, get a new string, using C# and C#6 features. Now in our toolbar, we'll see some brand new drop-downs. We can see here I have my iPhone 5S selected, and if I had a physical iPhone plugged into my Mac, I'd actually see it in that list. We have other toolbar options here for iOS to ensure that you're up and running connected to your build host. I've selected the iPhone 5S in my dropdown. I can simply start debugging. This will build and compile my native iOS application and bring it up right on my iOS simulator. Here we go, our iPhone simulator is up and running. I have my click button, and now every single time I click, we increase the count, and we have a new string that's set to our button text. And now, of course, I have my switch that I put here in the designer. But what about Android? Let's take a look at our new app.android. Here we have resources, and if I zoom in, we can see it has all of the native Android resources, such as drawables, layouts, and values. And layouts here are all of our XML overviews of our single pages. Main.android XML gives us a little button that says Hello World, click me, but I still have access to all the toolbox and UI Android widgets, and of course all the properties down here as well. I can see what this looks like in landscape mode or in portrait mode, different versions of Android. I can see the actual source and the code behind. Now, every single Android XML has some code behind it as there. So here's the main activity.cs. We have the same exact code that we saw over on iOS. We have our public count, get set, increase count, and here we simply find the view by ID and increase that count and set that to the button text. I'll set the Android application as my startup, and here we'll see any of the Android emulators you have installed when you installed Visual Studio, and I also have a physical Android device plugged in. I'll simply start debugging, and this will launch a debug session right on my device. Here we go, I have the button, I can simply click on it. Now I set a breakpoint in my C# code behind, and here we go. Sure enough, a full breakpoint, I can get all the IntelliSense that I want, including looking at the native Android widgets. I'll go ahead and remove that breakpoint and continue on. And we can see now, as I increase my count, building out native iOS and Android applications, all in C# inside of Visual Studio 2015. We just saw how to get started inside of Visual Studio 2015 to build out native iOS and Android applications all in C#. But what about code sharing? Let's take a look real quick at some popular code sharing strategies that will enable you as a C# developer to share 50, 60, 70% more code across all of your platforms. Now, I love portable class libraries. They enable you to build a single assembly to target multiple platforms. Simply select what you want to target, such as iOS, Android, Windows Phone, or Windows Store, and write all of your code in one project and share it across all your platforms. You can combine that with the power of NuGet to bring in popular libraries such as JSON.NET, an HTTP client, or Azure Mobile Services to bring these into your own portable class libraries and projects to add great functionality. In addition to portable class libraries and NuGet, we also have the ability to use shared code projects. Introduced in Visual Studio 2013 and available in 2015, it's a drop-dead simple way of sharing code across all of your different platforms. Let's take a look at these popular code sharing strategies to build out great native iOS, Android, and Windows applications inside of Visual Studio 2015. Here we are back in Visual Studio 2015. We just saw how to build out those native iOS and Android applications, but what about sharing code? When we created our application, it automatically created a shared portable class library for us, and it gave us a class. Let's see if we can share some code across our different platforms. Now we have this method here called increaseCount that's in our view controller, so let's go ahead and move that method and go into our class that's in our shared code and paste it in there. It's the same code that we're using on iOS. Now, in our view controller, we can simply declare our class, which right now is just doing some business logic and increasing the count, but it could be RESTful service calls or SQLite databases, or all of our models or view models. Then I can simply call shared and increase count. Now I can head over to my main activity, and my Android application have the same shared code with my button click handler and call that shared code. Now, what we can see here is that all we're doing is referencing our shared portable class library, and the same thing is true for our Windows Phone application. If I drop down my references, I have my new application. I could go to the code behind on my main page, and sure enough, if I come up and type in shared class and say my class, I have access to all of the same properties and methods in my shared code. Now I'm sharing code across iOS, Android, and Windows, all from a single portable class library. But what about a more complex application? Let's take a look at the Xamarin Store application. I'll pull it up for both Android and iOS. The Xamarin Store application is a pre-built application template that you can download and get up and running, and even order a free C# shirt. You can browse shirts for both iOS and Android, select your size, and even place an order. It has great animations. But what about this application? How is it structured? Well, let me flip over to my other instance of Visual Studio. And the Xamarin Store application has an iOS, Android, and a shared project. And our shared project has all of our business logic, our models, view models, and RESTful service calls with our client. Here, for instance, is our product with different product sizes, names, descriptions, and our web service. Our web service is going out, authenticating our user, logging them in, all asynchronously, and getting our product list and deserializing everything with JSON.NET. I could come into my Android application, pull in more NuGet packages, or go to our component store and add more components, which is a hand-curated list of great libraries for your business logic and your user interface. Here I could browse and add SAP or SignaturePad or Azure Mobile Services. I've already added it here to my application, so now right in my shared code, I could come into my usings and say using Microsoft.Windows-Azure.Mobile Services. Now I can access everything I know and add a great backend to this application. And that's just how simple it is to get up and running, building out great native applications, and sharing code across all the different platforms. Now, we just took a look at some popular code sharing strategies inside of Visual Studio 2015 with Xamarin to share code across iOS, Android, and Windows. And with Xamarin, you're always up to date with the latest and greatest technology. We've been shipping same-day support for iOS since iOS 5, and it's not just about phones and tablets anymore. We also have full support for Apple Watch, Android Wear, Google Glass, and all of the great Amazon devices such as Fire TV, enabling you to take your C# and .NET code to brand new emerging devices. Now, we took a look at the Xamarin platform today, which is just part of Xamarin as your complete mobile solution. Because we think about not just about building and designing iOS and Android applications, but what about the testability? Of course, you'll test your business logic with NUnit or XUnit unit tests, but what about the user interface? How do you ensure a great user experience across the tens of thousands unique devices in the market? Well, that's where Xamarin UI Test and Xamarin Test Cloud come in. Build C# automated user interface scripts with Xamarin UI tests and ship those to the Xamarin Test Cloud, where you can test your iOS and Android applications across thousands of physical devices. But what about after you ship your apps to the App Store? How do you ensure that you're getting feedback from your users with crash reports and analytics? Well, that's where Xamarin Insights comes in, enabling you to monitor your applications for iOS, Android, and all Windows platforms from just a single line of code. And we have great places and resources to get you started, not only with great documentation, but with live interactive instructions with Xamarin University, where you hop online and interact with real Xamarin University instructors to become a fully certified Xamarin developer. And Xamarin University offers a full free 30-day trial to get you up and running to build out great cross-platform native applications with Xamarin and Visual Studio 2015. Head to xamarin.com/university to learn more. And of course, if you just want to learn more about Xamarin, head over to xamarin.com. And to download the Store application and other great pre-built applications to get you up and running, head to xamarin.com/prebuilt. And thank you so much.
Hi, I'm Donna Malieri. I'm a program manager on the Azure App Service team. And today I'm going to talk to you about how you can build great cross-platform, enterprise-grade mobile apps using Azure App Service. In particular, I'm going to show you how you can make your app both responsive and resilient to network connectivity problems by using a feature called offline sync. So let's get started. First off, let me talk about Azure. Now, a lot of people, when they see this slide, they get a little nervous because they think they need to know everything that's here. And the fact of the matter is you don't. New services come out constantly, and I can tell you that even members of the Azure team have a hard time keeping track of what's new. The cool thing is that most of these services work independently of one another, even though they do provide additional benefits when they integrate. So if you take a look at this chart and you see one or two services that you might be interested in, you can learn more. And don't feel like you need to understand everything before you can start getting making use of Azure for your application. And basically, use what you need, and you only need to learn what you need to use. Today I'm going to talk about the so-called app platform within App Service, which includes web apps, API apps, mobile apps, API management, and notification hubs. In particular, I'm going to show you an app that has both a web client and a mobile client, and it also has a web job that it uses to do background tasks. So let's get started by taking a look at the capabilities that you get with App Service mobile apps. So this chart might be familiar to you if you're familiar with mobile services. In fact, we have the same sections on the right. You have your data connections. We've added some new ones. We have on-premise data connections now, including connectors with Salesforce and Dynamics. And we have a DocDB access, for instance. Authentication is handled the same as usual, and push notifications as well. A new feature that we've had relatively recently is offline sync. And the way that works is that you can sync whatever data source it is that you've configured for your mobile backend to your mobile client. And we have data sync available for all of our client platforms, with the exception of Cordova, which we're working on. So essentially, your client can abstract away knowledge of the underlying data source. So you could write your app connecting to a SQL Server, for instance, and then later change it to connect to Salesforce without ever changing any of your mobile client code. Now, a change that we made recently within the last year when we introduced App Service Mobile is to change the underlying compute that you use for your mobile backend. What we heard from customers was that they liked the flexibility that they got with mobile services, but they wanted more control over the compute container. We tried to make things easier by abstracting that away, but customers said, no, I actually want to be able to manage all of this. So now, with App Service Mobile, your backend is just a regular Azure web app, which was formerly known as an Azure website. So that means all of these great features that web apps has had for years and is continuing to innovate on are available to all mobile backends. So that includes things like Traffic Manager, VNet, App Service environments, and continuous integration and deployment. So I'm going to give you a couple of customer examples of some really cool apps that people have built that really unleash the power of Azure Mobile and make it so that they can focus on their app code rather than focusing on their infrastructure. So if you've ever traveled with Alaska Airlines, you may have used their mobile app. Now, they also have a huge number of employee apps. One such app is Hopper, which is how employees of Alaska, including flight attendants who need to travel for work, how they actually find spare seats on flights, and they can go from one destination to another. And they need their own system because they're not obviously paying for a ticket, and they need to see what flights are available. And they had an app for this before, but it used just regular classic ASP. It was not a responsive app. It didn't work offline. It didn't work on a mobile device. And it also had a lot of missing functionality. So a group of passionate engineers at Alaska said, hey, I bet you we could rewrite this and make it way better. And if we use Azure, that'll really boost our productivity. And so that's just what they did. They built this great Xamarin app that has fantastic internal reviews. And they use Azure Mobile, and including notification hubs, and connecting onto an on-premise data source in order to deploy this app. And they really have a lot of great things to say. If you want to learn more about this, check out the videos from last year's AzureCon, where they actually have some videos showing how they built this app. Now, you can also have consumer apps. There are a lot of great ones that run on app service. One example is the NASCAR results app that has a tablet version and a mobile version. And this app is interesting because it uses a lot of different Azure services, such as our New Relic integration, which is available through the Azure store, and of course Xamarin, which is very popular for mobile apps. And I'll show you a demo with Xamarin in just a moment. They use Redis, Microsoft SQL, and MySQL. And their website actually used PHP, which shows that Azure supports more than just .NET. Now, one more employee app, since that's the more common employee enterprise scenario that we're seeing lately, and that is the Transport for London fault reporting app. Transport for London is an organization that manages all of the transit in London. So if you've ever visited London, you've taken one of their services. Now, with a city that large, there's going to be issues that arise. There could be potholes, there could be some power line that's causing a problem for a bus, that kind of thing. And in the past, employees had to either track things down on paper and then enter them into a computer later, or carry around a heavy laptop to record these issues, because the issues need to eventually go on to some on-premise system. So what they've done is they've written an iOS native app that works offline that allows employees to take photos of issues, and this gets submitted back to an on-premise system. So in the case of Transport for London, they didn't want to move all of their existing infrastructure to Azure, but they did want to take advantage of these great offerings that we can give them, particularly in the case of mobile development. So they're using app service environments and VNets in order to securely connect back to their on-premise system. And these are just some of the examples. If you go to azure.com, you'll see that there's even more examples, including the very popular jet.com, who are hosting their mobile site on app service. So the key thing, to summarize, that Azure App Service gives you is a fully managed platform. It really delivers on the promise of PaaS that we heard when the cloud came out, but it's taken time for these services to mature, and over the past several years, Azure App Service has really come into its own as a fully managed platform. The other great thing about it is you don't have to rewrite your code in order to run an app service. You just write your code the way you normally would, a PHP site or an ASP.NET app, and you deploy it. You don't have to use a custom programming model. At the same time, you get all these great DevOps features like continuous integration and deployment, load testing, and you also get these enterprise features like VNet integration, Azure Active Directory integration, and so forth. So, developers like writing code, but most developers don't want to focus on infrastructure and servers. They want to focus on application code. And App Service really frees you up to be able to focus on your app and what it does that's special, not a lot of boilerplate. So let me show you a demo of a really simple app that has both a web client and a mobile client that we've built with Azure App Service. So let me switch now to Visual Studio. And here you can see that I have a Xamarin Forms app. It has targets for Windows Phone, Android, and iOS. And I'll be demoing the iOS version of this app. So let me show you the mobile version of this app. This is a really, really simple version of, say, Instagram. Like really, really bare bones. Doesn't have filters, it doesn't have tagging, but allows users to share photos. You can use social authentication or Facebook authentication. And you can upload images that are either shared or private to a user. So if we go to the web client, we can see some of these images that we've already uploaded. Now on the right, you can see there's some links to load different size images. And the way that that works is that when you upload an image from either the web or the mobile client, we have a web job that runs in the background that looks for a message that's posted to a queue. And when it sees that message, it loads up the blob and it does an image resizing algorithm in the background. And you can run this web job either on the same site that you're using to host your web and mobile backend, or on its own site. And I'm not going to show you the code for this web job, but this entire project is open source and available in the Azure Samples repository. So now let's look at the mobile version of this. So now in this case, I'm logged in using Facebook. And so I see, in addition to the default album, I see a new album called Cat Photos, which I haven't added anything to yet. So let me do that here. This is my cat. And it's taking a little while because it's uploading this image. And now it's uploaded. Now, if I click on these buttons, you can see that the image size is not available yet for the different sizes. The reason is that we are not synchronously resizing this image. Otherwise, that would make the mobile client wait, which would be kind of silly. Instead, when the image is uploaded, the client sends a message to an API, and then an item is added to an Azure queue, which the web job then listens for. Now, I talked about offline sync being a very important piece of functionality, particularly because you don't necessarily always have network access, or sometimes maybe you just want to limit the amount of data you use. And at the very least, you want an app that's very responsive. So as soon as it starts up, it should load the data that it loaded previously and not make the user wait. So let us simulate an offline scenario. In fact, let's completely take off the network. And so this means the simulator also has no network. And if we try to sync here, what we're going to see is it can't work. It can't sync your offline. So, however, we've just taken this really awesome cat photo. And so it's critical that we upload it as soon as we can. So again, it's showing a message because this app assumes that you're online. It's just saying, hey, just so you know, you haven't uploaded this image. And this image doesn't show up here because it is always using what's actually been uploaded to the server. But the image is still loaded into the app. So all I have to do is turn the Wi-Fi back on and pull down to refresh. I can do that from either the main view or the cat photos view. Now we can see that the cat photo is indeed uploaded. And if we were to do the same thing, but add to the default album, let's do this photo instead, we would see the same thing. So let me turn the Wi-Fi back on and sync it again. And now the image is loaded up. And let me go to my web client because I have to go to the default album. Let's refresh this page. And we will see, and here I'm not going to bother signing in. So here we will see this new image. Here we are. Now, the image resizing has kicked in and the web job has run and resized the image. Let me show you the code briefly for this to show you how easy it is to set up both offline sync and this new feature of uploading images in any kind of blob data actually, even when the user is offline. So first, what you need to do is have a mobile service client. You use our mobile client SDK. Here I'm using the one for Xamarin, but we have it for Android and iOS, as well as Cordova. And we create a SQLite store, which is how we're going to actually store the structured data, not the image data, but just the structured data. And then we create some local tables. Then we create sync context, which is essentially tracking all of these changes that we made while we were offline. And the other thing that we're going to do is set up the local store so that we get callbacks whenever there are local or server operations. And this is a new feature that we've added with our file sync support. And it means that you can either write your own code that synchronizes in the background and refreshes the UI by listening for these callbacks, Or in the case of the file sync API, this is how it actually finds out that there are new records, and then it makes queries to the server to find out what images are associated with them. In order to actually sync, it's super easy. You just push both the file changes and the regular changes and pull the albums that you want. In addition, when you're using file sync, you're going to want to write a file sync handler, which again is also really simple. You set a file data source. In this case, I'm using the dependency service pattern in Xamarin, and so I have a simple class that just loads different classes to actually load the image from the device, since that is platform specific. And then a file synchronization action is going to get triggered whenever there is a change to a file. So that's how that listener, that's why that listener is being used. It triggers this callback. So here, if you are, in the case of delete, we're going to delete the file. Otherwise, we're going to download the file. And that's how it works. And the key there that I showed you was offline sync. And the reason is that nowadays you can't always assume network connectivity, and users are expecting more from their apps. Even if they aren't some app that's critical to work functionality, people want to be able to use them and sync data later. The problem is that the reason that most apps don't have offline sync is that it's usually really hard to get this functionality to work. It's relatively easy if you only want read-only data, but as soon as you start changing data, and the data can be changed by multiple people or even just multiple devices, then the problem of doing sync becomes really hard. And so in the spirit of app service, in order to let you focus on your app code and not boilerplate and infrastructure, we have these client SDKs and server SDKs to make this super easy. So the reasons for doing offline sync are basically what I said. It could be just as simple as making your app responsive, or it could be the most interesting case where you have multiple users editing the same data, but you want to make sure that they don't stomp over each other's changes. So we also include conflict handling. So the way it works is that the client SDK, the offline sync feature of it, keeps track of all the changes that are being made when the app is offline, and it saves these to a queue. And then when the app detects that it has network access again, in the case of the app I was showing, it always checks for network access. And so the sync action is triggered by the user actually pulling down to refresh. At that point, the app calls the push and pull methods. And what push does is it finds all these changes that were in the sync context, and it sends them one by one to the server, ensuring that the operation is preserved. You can also use this feature in conjunction with Azure Notification Hubs and have your server actually send silent or raw push notifications to the client so that the client wakes up and then downloads data. And you can even do this in a background task so that the app always has the freshest data. So to summarize, what App Service does is that it provides the infrastructure so that you can run your mission critical or even not so mission critical web and mobile apps. You can have these apps scale with your business. You can start out small with the free tier and scale all the way up to hundreds of instances that run in an app service environment. So let us do the infrastructure and you can write your app. Thank you very much.
Hi there, my name is Ryan J. Salva. I'm a JavaScript developer and a product manager on the tools for Apache Cordova. I'm here to talk to you today about some of the new features we brought into Visual Studio 2015. Tools intended to help you interop with command line based tools like Grunt and Gulp and Bower and Node and all that kind of stuff that you're accustomed to using inside of typical JavaScript development. Hopefully, you'll also learn how to take some of your ASP.NET development skills and apply them back to mobile application development for iOS, Android, and Windows using the tools for Apache Cordova. Let's jump right into it with a demo. Here we go. All right, so one of the big changes between Visual Studio 2013 and 2015 is that we introduced a new project system. And to demonstrate how this project system works, I'm going to start on the Mac side of things. In fact, what I'm going to do here is I'm going to create a project using command line based tools. In this particular case, I'm using a command line tool called Ionic, which also takes advantage of Cordova. All right, so here we go. Ionic Start My App. We're going to stomp on the current project. Go ahead, do it. And here we go. It's downloading the Ionic app. Ionic is a framework that's primarily intended to create excellent native-like controls using HTML, CSS, and JavaScript, whereas Cordova provides kind of the underlying architecture that allows you to communicate with native code across the WebView bridge. Ionic provides the controls that give you radio buttons, tabs, list views, things like that. All right, we've got it created, so now we're ready to switch on over into that directory. And let's see what that looks like inside of the iOS emulator. So we're going to say Ionic emulate iOS. Now what it's going to do is it's going to build the application and launch that iOS simulator right here on the Mac side of things. Here we go. The simulator is coming up in the background, and here it is, the app launching a la Cordova. You'll see here that this has got a real native-like look and feel. Everything that you see here is HTML, CSS, and JavaScript, but it looks just like native controls. We've got smooth animations that navigate between views. We've even got form controls, just like you'd expect to see on a settings page. Looks pretty real to me. All right, so now let's kind of switch on over to use the exact same project, but on Visual Studio. All right, I'm over here in Visual Studio Online where I've uploaded my project from the Mac using Git. So now I'm going to open it up in Visual Studio. In fact, let's kind of go right over here, and in Visual Studio, I've already pulled that guy down and cloned him. So at this point, what I need to do is I need to actually open up the project. Here's one important difference between Visual Studio 2013 and 2015. Because when we changed the project to become interoperable with node-based tools like Grunt, Gulp, and Bower, we adopted a file system-based project. In fact, this is the exact same file system that's used by ASP.NET projects, ASP.NET 5 projects. So what we're going to do is we're going to open it up from the file system where we cloned it from existing code. This is a brand new dialog here, and what this dialog is going to do is basically translate that file system-based project into a project that Visual Studio can understand. You'll notice here that the very first option that comes up is Apache Cordova project. Now all we got to do is find the project on our file system. That's pretty easy. I know where it was located from when I cloned it. And this particular one, I just named it My App PC because we're on the PC side of things. All right, select folder. And now let's give it a name. Let's call it My App PC just to keep things consistent. All right. Now it's bringing in the project, and you'll see that there's a little lock, kind of a source control icon on all of those files except for one. That's that taco.json file right down here. Taco.json is essentially the project system file. This is the equivalent of the solution file, and this is the only thing that was not present in the project that we created using the Ionic command line back on the Mac side of things. One other thing that you're going to see here is that we've got a brand new node called the Dependencies node. And right now, it's got a little notification on it saying that it's restoring. What it's doing is it's restoring all of the node packages that did not get checked into Git. This is the exact same node that you would find in an ASP.NET 5 project, where you would go to manage things like Bower, Grunt, and Gulp tasks and the like. It's essentially an expression of all of the packages that are defined in your package.json file down here. So while it's going back and it's restoring those, let's take a look at this. In our package.json file, you see dependencies for Gulp, Bower, little shell.js action, and Cordova itself. In fact, there's about 5 plugins here. There's the device plugin, the console plugin, the whitelist plugin, which is new to Cordova 5.0, the splash screen plugin, and the keyboard plugin. All of those Cordova Dash plugins are directly from the core list of plugins that Microsoft contributes to in the Cordova open source project. The Ionic one is special to Ionic. Now that the dependencies node is finished loading, you'll see here that we've actually got an expression there of all the Bower and NPM packages that we found right over here. One of the great things that I get out of a file like this is premium IntelliSense that you wouldn't find in something like, I don't know, Sublime or Vim. Let's actually kind of take a quick look at how that would work. So I'm going to kind of put some empty quotes in here so that we kind of see it, and hit kind of quote there, and you'll see it's instantly pulling back actually from NPM what the latest stable release is of the Gulp package, along with a couple of regular expression variations of that package, so that I can develop in confidence and kind of accommodate minor version bumps that happen over time. Pretty cool stuff. We're actually going to go with the most recent version here, 3.9, bada bing, bada boom. All right, the last thing that I want to talk to you a little bit about is the transition from Visual Studio 2013 to 2015. Because we changed the project system between 2013 and 2015, that means that there are some breaking changes between the two projects. When you move from Visual Studio 2013 to 2015, you are going to have to make a couple of changes. Let me show what it looks like when I try to open up a Visual Studio 2013 project. Here on my desktop, I have got a 2013 project. I'm going to try to open this guy up, and since I don't have Visual Studio 2013 installed on my machine, it's going to try to open up with 2015. Once that guy tries to load, you're going to get a message right here in the Solution Explorer saying that it's incompatible. No worries, it's really easy for you to migrate that project to 2015. Here's what we're going to do. We're going to close the solution first, and we're going to create a new 2015 project. We'll create a Cordova blank app. Don't need to save that changes to that guy. And then all we need to do is from the File Explorer, open up our 2013 project, and you'll notice that there's a one-to-one mapping between the folders that are here on the left-hand side in 2013 and the folders that are available to us in 2015. There's no fundamental difference in the content between these files and folders. It's just how they're organized. So it's a simple copy-paste to go from 2013 to 2015. CSS, images, and scripts go into your www folder. Merges and res go here into the project root. So hopefully that was a fun ride and you learned something. If you'd like to learn a little bit more about how to use Grunt, Gulp, Bower, Node with the tools for Apache Cordova, how you'd like to maybe use your ASP.NET website for a Cordova project, or if you'd like to migrate your Visual Studio 2013 project to 2015, check out one of these links. Until next time, I'm Ryan J. Salva. Happy coding.
Hi, I'm David Stevens, a program manager on the Visual Studio team. In this video, you'll learn how Visual Studio 2015 provides powerful diagnostic tools to help you create cross-platform Apache Cordova mobile apps that your customers will love. First, I'll give you an overview of the JavaScript, TypeScript, HTML, and CSS diagnostic tools in Visual Studio 2015. And I'll explain how you can use this single suite of tools to fix problems in apps running on multiple platforms. Next, I'll show these features in action with a short demo. And finally, I'll provide you with resources to learn even more about how Visual Studio 2015 can help you achieve your cross-platform mobile development goals. Visual Studio 2015 helps you find and fix issues quickly in your Apache Cordova apps. We know that tracking down JavaScript bugs is one of the most frustrating and time-consuming aspects of your development process. So we've taken the same JavaScript debugging experience that web developers have enjoyed in Visual Studio for years and enabled it for Apache Cordova apps. From Visual Studio 2015, you can set breakpoints in Apache Cordova apps, step through code line by line, mouse over expressions to see their values, use the JavaScript console, and more. All of this even when your app is running on a tethered iOS or Android device. And if your app uses TypeScript, there's deep TypeScript debugging support in Visual Studio 2015. You can debug your TypeScript code directly instead of debugging the compiled JavaScript. This is possible because Visual Studio supports source maps, a de facto standard for debugging compiled to JavaScript languages. Visual Studio 2015 can also save you time while developing your app's UI. It's disorienting to jump back and forth between your editor and your browser tools while perfecting your HTML and CSS. Visual Studio 2015 simplifies this process by integrating familiar HTML and JavaScript tools right into the IDE, so you can easily navigate the DOM tree of your app. And with live code editing, you can make changes to your HTML in Visual Studio and see your changes instantly reflected in the browser. No page refresh required. The best part of Apache Cordova is how it allows you to leverage a single code base to target any OS and any device. But when it comes time to diagnose problems in your app, this cross-platform reach introduces new challenges for you as a developer. Different platforms require you to learn and use different diagnostic tools. We've heard how you'd like to leverage a single suite of tools across browsers, emulators, and tethered devices. And that's exactly what we've delivered in Visual Studio 2015. For fast, iterative development, you want to run your Apache Cordova app in the browser, where you can spot problems quickly and make adjustments without spending time building your app for a particular OS. So in Visual Studio 2015, we've added support for the Chrome Remote Debugging Protocol to make this possible. You can launch your app in Chrome from Visual Studio 2015, then use the Visual Studio JavaScript Debugger, JavaScript Console, and DOM Explorer just like you'd expect. Under the hood, Visual Studio 2015 takes care of communicating with Chrome so you can focus on debugging your app, not switching back and forth between tools. Similarly, we've enabled debugging against Android emulators, the Windows Phone 8.1 simulator, and Windows apps running locally on your development PC. We support Android's Google emulator and Genymotion, but if you haven't checked out the new Visual Studio Android emulator, you should. It's super fast, and it's already installed if you have Visual Studio 2015 with tools for Apache Cordova. Finally, when you're ready to test your Apache Cordova app on a real Android, iOS, or Windows device, Visual Studio 2015 is there to help. From Android and Windows Phone, it's as simple as plugging your device into your PC, putting your device into developer mode, and deploying from Visual Studio. For tethered iOS device debugging, you need a properly configured Mac on your network. Then you can use Visual Studio 2015 on your PC to deploy and debug your app on the iOS device through the Mac. You can learn more about device debugging on MSDN. All right, let's see some of these features in action. Here I have Visual Studio Community 2015 with an Apache Cordova app project loaded. It's a simple to-do list sample app written with Cordova and Angular. If you want to try this yourself, download Visual Studio Community 2015 for free from visualstudio.com. This sample app is available by searching for AngularJS To Do in the Online Samples tab in the Visual Studio New Project dialog. First, I'm going to launch the app in Chrome to quickly check it out. To do this, I'll click the little green play button that says Ripple Nexus Galaxy. This will build the app with Cordova, then run it inside the Ripple simulator in Chrome. Just to make sure it works, I'll add a new to-do. All right, great, it works. Let's take a look at the code. I'll go to my controller.js file back in Visual Studio. In my add to-do handler, I'll add a breakpoint on the first line here. Now when I add a new breakpoint, or add a new to-do item, you'll see it breaks back in Visual Studio. I can mouse over variables to see their current value. And when I step over, you'll see these values change. So text was just undefined and now it's mow the lawn. I can add a watch by selecting a value and say add watch, and it appears down here in the watches tab. And now when I step over, you'll see the value change. So this is a really great way to sort of keep track of the values of variables as you move through your code. The Locals tab and the Call Stack tab are also useful for understanding the state of your app as you debug. Now let's check out the DOM Explorer. While your app is running, you'll see this DOM Explorer tab in Visual Studio. On the left, we have the HTML of the page. You can use the Select Element tool in Visual Studio to choose elements in Chrome. On the right, we have the styles for the currently selected element. The Computed tab shows real-time values for each style property for an element, and you can use the Layout tab to understand the layout box model for the element. If you want to tweak something in your UI, you can do it right here from Visual Studio. For example, let's change the text in this input box. I have it selected, so I'll just double-click the text here and change it, and press Enter, and the change is instantly reflected back in Chrome. Finally, the JavaScript console is useful for reading errors and messages from your running app and evaluating lines of JavaScript in the context of the page. You can see I already have a handful of messages and warnings here, And if I click on any of these locations, I'll be taken to the corresponding file in Visual Studio. If I type a variable here, let's say document, you'll notice I get IntelliSense against the values currently in Chrome, so we're communicating with Chrome to do that. And this even works if I sort of dot into the variable. See all these things on the document variable, and if I evaluate it, you'll see the value just like you'd expect. All right, quick recap. Visual Studio 2015 has a full suite of diagnostic tools to help you build amazing Apache Cordova apps. If you've used Visual Studio before, they'll feel immediately familiar. And if you haven't, we hope you'll give them a try. The best part is that Visual Studio 2015 lets you use this single tool set for apps running in Chrome, in local Android and Windows Phone emulators, and even on tethered Android, iOS, and Windows devices. For more information, check out visualstudio.com/CordovaVS and follow @Visual Studio Cordova Tools on Twitter. If you have ideas for ways our tools could be even better, send feedback at visualstudio.uservoice.com. Thanks for watching.
Hi, I'm James Montemagno, Developer Evangelist at Xamarin. And today we're going to see how you can build wearable applications for Apple Watch, Android Wear, and extend Microsoft Band, all using C# with Xamarin. First, we're going to take a look at the entire Xamarin platform to build out native iOS, Android, Mac, and Windows applications all in C# in Visual Studio. And then we'll see how to extend those applications for Apple Watch and Android Wear all in C#. Then we'll take a look at the brand new exciting SDK for Microsoft Band to extend any of your applications to integrate with the Band itself. And of course, I'll show you exactly where to get started. Now we're going to focus on the Xamarin platform, which is where you're using Visual Studio to build out native iOS, Android, Mac, and Windows applications all in Visual Studio, C# and .NET. Now what's great here is that you can use all of your favorite tools to now extend to great wearable devices. The Xamarin platform for mobile development is extremely unique. We enable you to build a shared C# backend, all of your platform-independent business logic, models, view models, SQL databases, RESTful service calls. And then we give you the tools right into Visual Studio to build out a native iOS, Android, and Windows user interface. All while sharing that shared C# backend, 50, 60, or 70% more of your code shared across all platforms. And this, of course, extends now over to wearables. You can still use your shared C# backend and tie in an Apple Watch, Android Wear, and integrate with Microsoft Band. We have great designers for Apple Watch built right into Visual Studio, and these are extensions of an existing iOS application, so you can design, integrate, and develop all of your applications, including Apple Watch, right in Visual Studio. And the same is true for Android Wear as well. Extend and add a companion application easily right inside of Visual Studio. Let's take a look right now on how to use Visual Studio to build Apple Watch and Android Wear applications all in C#. Here we are inside of Visual Studio 2015. Now once you have Xamarin installed, you just hit File, New Project, and you'll see some Android and iOS project templates. Now to get started with Apple Watch or Android Wear, you'll already want to have an iOS application or an Android application set up. You'll do that by selecting iPhone and creating a blank application or Android. Then you'll add an Android Wear application or an Apple Watch application, and the entire project setting will be set up for you. Now, I already have an application here called the Scott Hanselman application. It shows a series of blog entries and tweets that Scott's been up to. We can see in our Solution Explorer, we have our Android application and our Android Wear application. But let's first cover iOS. We have our iOS main application, which is a complete overview of everything Scott. And then we have a Watch app and an extension. The Watch app itself is the physical application running on the Apple Watch, and it only contains static files such as storyboards, a complete overview of our application. The Watch extension is a mini application running side by side your main iOS application. So we can see we have some shared code here, some tweets that are coming in as well. Now, in our Visual Studio Designer for iOS, you can build out your Apple Watch user interface directly inside of Visual Studio. If you want to add something such as a button, you can drag and drop it on. If you want to add code behind, simply double click, and the code behind event will automatically be entered for you. Anything that you could do in a storyboard designer for iOS, you can do here, but just only with Apple Watch controls. You have a full property pane available to you, so you can modify anything that you'd like. Now, if we come back to our Android application, we can look at our main Android Wear application. Something that's unique about Android Wear and how it works is that it's a full-blown Android application running directly on the Android Wear device. If we take a look at one of the layouts, it's going to look very familiar to what we saw if you've ever built out an Android application. Here is our designer built right into Visual Studio. Again, a full toolbox available for you, such as laying down additional text. And of course, this is generating the Android XML code behind. Now, in this instance for the Hanselman application, we have the application running here on one of our devices. We can take a look at all of Scott's tweets. And if we pull up our actual Android Wear application running on a physical device, we can actually browse through all of Scott's tweets in real time. And it's just that simple to extend an existing application all powered by C# right inside of Visual Studio with Xamarin. We just saw how to build out Apple Watch and Android Wear applications all in Visual Studio with C# and Xamarin. Now those are companion applications, but Microsoft Band and its SDK gives you a unique experience to extend an existing application and read amazing sensor data from the Microsoft Band itself. Things like accelerometer, gyroscope, UV, and device contact information. In addition, there's also app tile support, so you can actually push messages from your actual phone application to the Microsoft Band. The simple sensor data gives you a nice async or waitifyable API to pull in sensor data with just a few lines of code. And then additionally, the simple messaging API enables you to send a message from your app to the band with just a single line of code. Let's see how to get started today integrating the Microsoft Band SDK into one of your existing applications. Here we are back in Visual Studio 2015. We've been building out our application and extending it with companion applications for Apple Watch and Android Wear. But what if we wanted to extend our current application running on the phones to integrate with Microsoft Band? Well, to get started, you'll notice in both our Android and iOS applications, there's a folder called Components. When you right-click and say Get More Components, this will open the Xamarin Component Store, a hand-curated list of amazing libraries for all of your Xamarin iOS, Android, and Windows applications. Simply type in Band, and you'll see the Microsoft Band SDK preview. She'll give you resources on how to get up and running. Now, I've already installed it here, so I can simply now double-click on the Microsoft Band SDK preview under the Components folder, and I get a full Getting Started guide of how to easily integrate into all my iOS, Android, and Windows applications and connect to the sensors on any of these devices. The same is 100% true with my Android application. It's just that simple to download the SDK and get started integrating the Microsoft Band SDK in any of your mobile applications. Building Apple Watch, Android Wear, and integrating with Microsoft Band SDK are all part of the Xamarin platform. This is where you, as a C#.NET developer, are building out native iOS, Android, Mac, and Windows applications all in Visual Studio. But Xamarin is much more to that. In fact, we're your complete mobile solution, because it's not just about developing, it's also about testing. And that's where the Xamarin Test Cloud and UI tests come in, enabling you to build out automated user interface scripts for any of your iOS or Android applications. Run those scripts locally on a simulator or a device, or ship them to our test cloud and test them on thousands of physical iOS and Android devices. But what about after you ship your applications to the store? How do you get feedback from your users, analytics, or crash reporting? Well, that's Xamarin Insights. With just one single line of code, you get managed and native crash reporting all in real time. And of course, we have the best platform for learning all of this with Xamarin University, live interactive training where you become a full Xamarin certified mobile developer. You can get started today by going to Xamarin.com, downloading and starting your free trial. Thank you for watching.
Hello, my name is Varun Gupta. I am a Senior Program Manager for the Microsoft Visual Studio team. Today, I will talk to you about securely deploying mobile apps for enterprises. Mobile apps are becoming increasingly important for enterprises. Security of these apps and data protection is extremely critical. Today, I'll demonstrate capabilities of Microsoft Intune to deploy these pure native apps for iOS, Android, and Windows built using Xamarin. As you're aware, Visual Studio with Xamarin allows you to build pure native iOS and Android apps. These apps are built using native UI designers and share business logic across platforms. These apps are compiled to 100% native as per the platform. Therefore, these apps look and feel like native applications. More importantly, you can build these beautiful native apps very quickly using C# and familiar Visual Studio environment. These apps have access to 100% of iOS and Android platform APIs. Thousands of these companies are using this technology to build native apps using existing C# skills. You can find more about it at visualstudio.com. Secure deployment of apps is critical for enterprises. Intune App Management enables enterprises to meet these goals with almost no change to their existing app development process. Enterprises can securely deploy and manage apps. Enterprises can configure their apps to manage encryption, set security policies such as PIN enforcement. It can even prevent users to copy-paste from specific apps. These are just examples of security policies that can be set. We understand that different enterprises use different tools for building mobile apps. Hence, Intune App SDK works with a variety of tools. For example, apps built using Xcode, Android Studio, Cordova, or Xamarin all work with Intune. Today, I will demonstrate how quickly you can securely deploy and manage native apps built using Xamarin with Intune. Note that you can use Intune to manage your devices or apps or both. You could be using different software for managing your devices, and you can still use Intune to easily manage your applications. Now we'll switch to demo. I'll quickly demonstrate how easily you can manage your existing app with Intune. I have an app that I would be using for the demo. This app is used to manage mobile health clinics. This app is already built. Now we want to securely deploy this app to the enterprise and manage the security policy. So you would see in the demo that we will install Intune App SDK, add a couple of lines of code, and then deploy on Intune portal with specific policy. It's straightforward. You'll see it's just a few steps and we'll be all set up. So I have the iOS version of the app opened up in the Solution Explorer. What I'll do is I'll go to the Components tab and I'll click on Get More Components and add the Microsoft Intune component to it. Once that component is added, your project is configured to use Intune. Now what we'll do is we'll go to the main iOS file, the appdelegate.cs, and add a line of code that calls Intune. And that's it. We are all set. If you also want to manage encryption for your application, you need to go to entitlement.plist file and provide Intune access to your keychain group. What this does is this allows Intune to manage encryption for your app data. And that's it. We are all set up with this application, and this is configured to use with Intune. We'll build this application and then deploy on Intune portal. Now we'll switch to the Intune portal. I have it manage.microsoft.com. This process would be done by the administrator. So what the administrator would do is upload this application first to the portal. Note that you can upload the application to a public store, and then Intune can reference application from there, or you can upload it only to your company-specific Intune account. So we will first add the app from here. We'll provide the location of the app, and the app would be uploaded to the Intune store. Then the next step would be to set up a security policy. For example, for this particular app, I have set up a policy. Now, let me walk you through a sample policy. Note that these policies can be modified per application, or a lot of apps can just reuse a similar policy. So for example, in this particular policy, what I'm doing is I'm specifically requiring a simple PIN for access. I'll also modify any of the timeout requirements when the PIN should be re-entered, and I'm also requiring encryption of any app data. One interesting aspect is that I am also restricting the cut, copy, paste in this particular app with any other applications on the phone. So I'll demonstrate this later on when we look at the app. Now we'll go ahead and save the policy. So now our app is uploaded onto Intune portal. We have created a policy, and then what we'll do is we'll just set up the app to use that policy. So we'll go to the apps menu. This is our app, the health clinic applications, and we will basically specify policy for this app. So we'll basically say that this app goes to our enterprise users only they can download it, and here I get to choose which of the policies I want to apply. So we'll go ahead and apply this policy. Now the next step would be the actual user in the enterprise will look at this application on their mobile device and look to install it from the company portal and also use this application. So we'll now walk through that experience for an enterprise user. So what I'll do is I will open the company portal application, and I will see the list of apps that are authorized for my use. I will go ahead and install the health clinic application. I've already installed that, so I'll go ahead and open the application. Note that as soon as the application comes up, it shows a screen to enter PIN. Note that we had enforced a policy for a user to enter their PIN. And note that the developer didn't really need to do anything, just added one line of code and they were done. And all of this experience is coming from the Intune. So here's my app, beautiful app, and no impact to performance. What you don't see here, but what's happening in the background is that we also set the secure encryption of any app data. And that's happening automatically in the background. This app is securely managed via PIN, and as well as the data is encrypted. We also set policy to avoid users to be able to copy paste or transfer data from this app to anywhere else. This is specifically important for industries such as health industry. For example, if the user would try to email, they would be blocked. And if they try to copy paste the content, let's say they copy the content. Now, if they try to paste it in any non-company application, what will happen is that Intune will prevent pasting of any app, of any content. So what this demo shows is end-to-end experience of being able to securely manage and deploy your enterprise-grade applications. It's very easy, simple for an app developer to configure app to use Intune. Just few lines of code, add reference to Intune. It's very straightforward for an admin to upload the app and set a security policy for it. And as we saw, the experience for end users is very straightforward and intuitive. So this is all I had for today. If you want to read more about it, visit Intune at Microsoft.com website. Thank you.
As a mobile developer, you can likely appreciate the benefits of automating your app's build, test, and deployment process. Unfortunately, getting this reliably set up isn't always as easy as it should be. I'm Jonathan Carter, and in this video, I will show you how Visual Studio Team Services helps you quickly set up and maintain a mobile DevOps solution that lets you focus more on your app and less on your automation. Visual Studio Team Services makes it easy to set up a continuous integration server for your mobile client, regardless if it's built using Objective-C, Java, C#, or even JavaScript. It includes cloud-hosted build machines, so you don't need to worry about installing any software. And we've partnered with Mac&Cloud in order to support your iOS builds as well. Integrations with Xamarin Test Cloud and Perfecto Mobile make it easy to run your automated tests against the breadth of devices your apps support, as well as the extensions for HockeyApp and CodePush that make it simple to ensure your testers and end users are always up to date. Let's see how this looks. Creating your build definition is simple thanks to the provided templates which can get you started for the various mobile app platforms, including Xamarin, Xcode, as well as Visual Studio-based templates. Your build definition can run based on check-ins from Visual Studio Team Services, GitHub, as well as whichever Git server your team may be using for version control. Once you've created your build definition, the catalog of pre-built tasks makes it simple to compose together a pipeline that is as comprehensive as your needs. Using the Xcode build task, you can easily build and sign your iOS applications. In addition, using the decrypt file task, you can choose to check in encrypted versions of your certificate and/or provisioning profile. That way you can easily build ad hoc or even store distribution versions of your applications. Using Mac&Cloud, you can easily configure an OS X build agent to your Visual Studio Team Services account. That way, when your Xcode builds ultimately run, you can generate the iOS assets that you need without having to manage your own OS X hardware. Once you've configured your build definition and kicked off a few builds by checking in code to the configured repository, you can check the status of your builds easily to see where they've failed and where they've succeeded. For builds that have failed, you can drill in and see the specific task in the build definition that actually caused the issue. That way you can easily diagnose what went wrong with your build and then understand how to best diagnose it. The built-in Gradle task allows you to easily build your Android applications, as well as configure the specific Gradle task that you want to run as part of that automated build. In addition, because VS Team Services already provides cloud-hosted Windows build machines, kicking off an Android build is as simple as simply queuing one up. You can easily build your Xamarin applications for Android as well as iOS using the built-in tasks in Visual Studio Team Services. In addition, the Xamarin License task allows you to easily automate the activation and deactivation of your license so that it's only active during the point that your build needs to occur. Finally, the built-in NuGet installer task allows you to restore and acquire any third-party dependencies your Xamarin application may have in order to successfully build your app. Once you've installed the Cordova extension from the new Visual Studio Marketplace, your build definition pipeline will be able to add a new Cordova build task that handles automatically generating the binaries for your application for both Android, iOS, and Windows. In addition to just generating the build, it also has capabilities for handling the signing for each of the 3 platforms as well, which is great because that tends to be a pretty thorny issue to have to solve. Now, once you're building an application with JavaScript, it's likely that you're also using NPM to pull down dependencies. There's a built-in task to automatically acquire those as part of your build. And finally, it's also pretty common to use Gulp to run unit tests as well as do any compilation of languages like TypeScript or Sass, and the built-in Gulp task automatically helps you ensure that your application is fully built and ready to create your Cordova binaries. Beyond simply automating the build of your application binary, it's also very common to want to run unit tests as well. If those unit tests were published to Visual Studio Team Services, as part of the build success or fail summary, you can also see the results of your tests. If you click into the test results, you can see a breakdown of all of the tests that ran, which ones passed, which ones failed, and you can even open bugs to track any failures that may have occurred during a specific build. Once your app has been built and passed all tests, you can automatically deploy it to testers via HockeyApp using the new HockeyApp extension, which provides a deployment task to automatically submit your AppX, IPA, or APK file from VSTS to your HockeyApp account. That allows you to easily, continuously deliver updates to your testers without having to manually go into the HockeyApp portal to do so. When your app is ready for production, Cordova and React Native developers can automatically publish their JavaScript, HTML, and CSS assets to the CodePush service. This way, beyond simply automating the delivery of updates to your internal testers, you can also automate the delivery of updates to your end users. So as we saw in the demos, no matter how you're building your mobile app, Visual Studio Team Services can help you automate the build, test, and deployment process of your mobile DevOps solution. We hope you check it out. If you want more information on Visual Studio Team Services, CodePush, HockeyApp, or other topics that I discussed, check out the other videos in the resources listed below to go deeper into these areas. Additionally, follow us on Twitter and watch the VS blog in order to stay current on new functionality, as well as new best practices, testimonials, and tips. Thanks for watching the video. As a mobile developer, have you ever found yourself wanting to release app updates more quickly? Potentially to respond to a critical bug fix, or even to flight a key new feature? I'm Jonathan Carter, and in this video, I'll show you how the CodePush service can help you engage more directly with your end users by instantly updating your Cordova and React Native apps. The CodePush service works by acting as a central repository which developers can publish updates to, and that apps can query updates from. Once you've initially distributed your app through whichever stores are appropriate for your end users, you can begin releasing updates directly through CodePush. This provides you with a deterministic, web-like agility experience, as well as complete control over the actual update UI that is presented to your end users. Let me show you how this works. Once you've registered an account with the CodePush service, you can begin managing your apps as well as releasing updates using our node-based CLI. So using the command that I have displayed here, you can install the CLI locally, but in my case, I've already installed it. Once you've done this, if you run code-push from your terminal, you will see all of the subcommands that allow you to manage your apps, do releases, authenticate with the service, as well as a handful of other capabilities. So in this demo, I'm going to show the getting started experience for a Cordova app. And if you want to see the details for hooking up CodePush to a React Native application, please refer to the website and documentation. So first and foremost, we need to let the service know that we want to create an app and have it allow us to release updates to it. So what we'll do is say CodePush app add, and we'll just call this simple demo connect demo. And what this is going to do is notify the service of this app, and the service will automatically create what are called deployments, which allow us to have multiple versions of our app in flight at any given time. So you'll notice by default it gave us a production and staging, which is particularly useful if you want to use CodePush to test out features or bug fixes before actually submitting them to end users. So to get started adding CodePush to the app, let's copy this deployment key, which we'll use in a moment. So for Cordova, the way to CodePushify an app is to add the CodePush client to your application, just like any other plugin. So if you say Cordova plugin add, the name of our plugin is called Cordova plugin CodePush. So you run that. In this case, I already have it installed, but you'll see that this is how you would add that. Once you have your plugin added to your application, there are just a few simple steps that you need to configure it so that when it makes the checks for update, it can actually succeed in getting the right changes. So first, in your config.xml, you need to tell the CodePush client which deployment key you want to use to actually check for updates. So in this case, I just pasted in the deployment key for the staging deployment that we just created in the CLI. Secondly, you need to make sure that the codepush.azurewebsites.net URL is added to your root pages CSP. That way, from a security perspective, your app is allowed to actually make checks for updates using the CodePush service. And then finally, you just need to add a line of code to your app that actually does the check for updates. So in this case, when you added the plugin, you have a new global object added to your app called CodePush, which has a method called sync. Now there are more advanced APIs to do a bit more customization of the actual experience of checking and downloading for an update, but in this case, sync is sufficient for showing a very basic and acceptable end user experience. So now that we've made these changes, let's go ahead and run this app, deploy it to the Visual Studio Android emulator. And what we'll do is we'll attach the Chrome DevTools to it so that we can see that there is no update available, make a change, release that through CodePush, and then actually see that change take effect. So let's give this a minute while the Gradle build is happening, and then it'll deploy to the emulator with this is the exact app that we're seeing. So let's go over to Chrome, and you'll see here's the Hello World app that we just deployed. So if we go to the console, you'll notice here it says the application is up to date. So this is the CodePush plugin checking the server using the deployment key that we configured. So what we want to now do is let's go back to the app and make a very trivial change, and then we'll actually release that through CodePush and see it get picked up. So here we'll just go to the h1 element of the root page and add this string connect to the header. So to actually deploy this change to the CodePush service, you first need to actually do a Cordova prepare, which will take all of your www files, do any platform-specific merges, in this case Android, and make sure that you have the right set of content that you want to deploy to your users. So then you can do a CodePush release where you specify the name of the app as well as the directory that you want to release. So in this case, it's going to be platforms, Android, assets, www, which is the Cordova Android folder that represents the prepared set of files for this application. And then finally, you need to specify what is the native version of the app that corresponds to this change. So if we go to our config.xml, you'll see that right now our app version is 0.0.1, and so I'm just simply telling the service that that is the version that is needed for this CodePush update to be effective. So if we go ahead and run that, you'll notice that the release was successful. If we bring back the app and go back to the Chrome console, what I'll do is simply reload the app to force it to rerun the CodePush sync logic. And so here you see CodePush plugin give us a log message saying an update is available, and we get this message displayed. An update is available, would you like to install it? we can go ahead and ignore that and move on with using the app. Now, the reason we were able to ignore it is because we did not specify that the update was mandatory when doing the release. Now, let's do a reload again, and here we see that the update is presented to us yet again because we did not install it the previous time. So we'll do an install. That will download the update, apply it, and then restart the app. So here you see the connect string that we added. Once again, if we go back to the console, you see that the plugin is now saying the application is up to date. We can do a reload just to verify that that is in fact the case. And so now that the update has been applied to the app, it is smart enough to see that there are no changes for this exact deployment. So this demo only just scratched the surface of what is actually possible with CodePush. To check out more information and docs on getting started, please refer to our website linked in the resources slide. Also, please feel free to reach out to me via email and/or Twitter with any and all feedback that you may have. Thanks for watching.
Hi, I'm James Montemagno, Developer Evangelist at Xamarin, and today we're going to take a look at Xamarin Forms, enabling you to leverage your existing C#, .NET, and XAML skills to build out native iOS, Android, and Windows applications. Today we're going to cover Xamarin and Xamarin Forms to see exactly what's all included, and then we'll take a look at how we can leverage existing XAML and MVVM skills to build out those native iOS, Android, and Windows applications with a shared user interface. And of course, I'll show you exactly where to get started. The Xamarin platform is extremely unique, enabling you to use your shared C# and .NET libraries to build out a common backend for all of your iOS, Android, and of course Windows applications. And it looks a little bit something like this. Our shared C# backend is all of our business logic, platform-independent code, and .NET code, such as our models, view models, SQL databases, RESTful service calls. And then we give you the tools to build out a native iOS, Android, and of course Windows applications. And that shared code is anywhere between 50, 60, 70% or more. But with Xamarin Forms, it introduces a brand new optional shared user interface library, common controls across iOS, Android, and Windows Phone that sits on top of that shared C# backend. And inside of Xamarin Forms is a lot. It's 40+ pages, layouts, and controls that you can build from C# code behind or XAML to a data binding, a navigation library, animation, dependency service, and messaging center. So if you're familiar with MVVM, you're going to feel right at home. And of course, in Xamarin Forms, we have different pages such as content page, navigation, tab pages, and ways to lay out your controls, such as a stack layout, relative layout, or a grid. And of course, there's the controls. These are just a few of them here, and we'll take a look at more. Things such as buttons, editors, and entries, and labels, all available to you from shared C# code. Let's take a look at how we get started using Xamarin Forms today. Here we are inside of Visual Studio 2015. After you have Xamarin installed, you're able to say File, New Project, and get started with the Xamarin platform. You have brand new Android and iOS templates to build out native iOS and Android applications, all in C#. But if you want to get started with Xamarin Forms and the cross-platform UI layer, select Mobile Apps. You'll see some blank applications where you can use a portable class library or a shared code project. I'm going to select a portable class library, solution, and hit OK. This will automatically create my shared code, iOS, Android, and Windows Phone applications and tie everything together for me. And here we go. We can see our portable class libraries already brought in our Xamarin Forms references, and in our Android and iOS applications has already brought in and tied in our portable class libraries. Now the core of any Xamarin Forms application is the app.cs file. This is our application class, and it specifies the root of our application. Here's our main content page that's simply creating a label and setting the text to welcome to Xamarin Forms. Let's see what this looks like right out of the box. I'm going to set our Android application as our startup, and we'll start without debugging. Let's bring up our simulator, and there we go. Welcome to Xamarin Forms. If we come over now and set our iOS application as the startup, and rebuild this, we'll see the exact same application, Welcome to Xamarin Forms, but on iOS with the native iOS label. With it all compiled up, we'll simply say Start. And there you have it. If I run it on Windows Phone, we'll see the same thing. But let's add and make a little bit more complex application. I'm going to go ahead and create a brand new content page that I've copied in here. It says page 1, and it inherits from content page, which is a Xamarin Forms page. Here I have a simple button that says click me, a label that will reference how many times we've clicked that button, and we add those two items to our stack layout. This will stack them automatically on top of each other. And the final thing that I do is set the content of the entire page to that stack layout. Now we can come back to our application class, and instead of creating a new content page here, we'll say new page 1. Again, this is completely 100% in our shared code. So let's come and compile up our portable class library and our iOS application. We have click me right in the center, and every single time I click, it increases the count. If I come over to my Android application and we test it here, we'll see a native Android button and a native Android text view displaying the clicks. If we bring up the simulator, there it is, automatically, 100% from shared code. Let's see what this looks like on Windows Phone. There you have it, a Windows Phone button and the same code and logic from the UI and the business logic all being shared across iOS, Android, and Windows Phone. Obviously now we'd build out our full application with more models and views, but that was just a quick look at getting started. We just saw how to get started with Xamarin Forms, but what about MVVM and XAML support and data binding? Well, built right into Xamarin Forms is full XAML support. XAML is an XML markup language to build out user interfaces. Here we can see a stack layout with 2 entry controls and a button, with a username, password, and a click event all bound with a data binding syntax. But let's see exactly how that works. Well, everything is based on MVVM, which is an architectural pattern called model, view, view model. We start with the view. This is a representation of how we display our information. This is our XAML. Then we have our view model, which handles data interactions to and from our view. This is all of our business logic calls, such as handling click events or going off to a RESTful service. And then we have our physical data that's over here. These are our data objects that live in our databases or our physical JSON models. Now the beauty of MVVM is that it's not only just an architectural pattern, but it's one that fits in great with a data binding framework. This handles all the interactions between the view and the view model. So when you update your view, the view model properties in the code behind update automatically and vice versa. And Xamarin Forms has a full data binding framework built right in. So let's see exactly how that works though. Everything is based on iNotify property change. It's an interface that you implement in your view model that says whenever I change a property, raise a notification to anyone that's listening. How this would look, let's say for a first name property, is a getter and setter, and whenever I set the first name, I simply call onPropertyChanged and pass in the name of the property. Now anyone that's subscribed, such as Xamarin Forms, will automatically update the user interface. And we can create that user interface here in C# code behind by creating the label and binding the text property to first name, or use the beautiful XAML syntax to just say binding first name. Let's take a look right now of using MVVM and XAML to build out our native iOS, Android, and Windows applications. Here I am back in Visual Studio 2015. Now I already started building out a little application called My Stocks that uses Yahoo's API to pull down stock quotes in real time. I have some shared code, my models and my view models here, such as different queries that are being executed. If we take a look at my stock view model, this is where all the data binding is going to occur. I have a quote, company, year range that can all be set and my user interface can react automatically. The core here is this command, the getQuote command, that when executed we'll call getQuote. This uses all .NET code such as HTTP client to make a RESTful call up to Yahoo and then deserialize the JSON with JSON.NET. Then I'll be setting these properties where anyone listening, such as my Xamarin Forms user interface, can automatically update and respond. Now if I wanted to build out a little user interface, I'd simply say add new item, and then I'd see Xamarin Forms XAML page. Adding that in immediately enables me to add things such as stack layouts, labels, and dive in with Rich IntelliSense to add other things, maybe such as an activity indicator. I can set the is enabled to true, and I'd be on my way. Now I already built out the user interface here, and let's take a look at the stocks page. Here at our core is a stack layout with a label and an entry field that is bound to our symbol two-way. So whenever it updates in the UI, my code behind will be updated as well. I have a button with a green background and white text with a get quote command bound automatically, and I'm binding labels here to company and year range. So whenever my view model updates, my UI will react as well. One thing that's unique about Xamarin Forms XAML is that we have the ability to not only add styles, behaviors, and triggers, but also do platform-specific property setting. So here for this label of the quote display, we have a different font style for Android, Windows Phone, and iOS. Let's take a look and see what this looks like with our XAML in place. Here we are inside of Android with the Android look and feel. Going out, getting the quote. If I pull up Windows Phone, same thing with all native Windows Phone controls. And of course, over here on iOS, again, getting the quote. All 100% shared code from my business logic backend to my front end, all in XAML, powered by Xamarin and Xamarin Forms. So that's Xamarin Forms, part of the Xamarin platform, enabling you as a C#.NET developer to build out native iOS, Android, and Windows applications, all in Visual Studio. But of course, Xamarin is your complete mobile solution, especially when it comes to testing. We have Xamarin Test Cloud and Xamarin UI Tests, enabling you to build out automated user interface scripts for any of your iOS or Android applications. You can run those scripts locally on the simulators or devices that you have, or ship them to our Test Cloud, where you can run those scripts on thousands of physical iOS and Android devices and get reports back nearly immediately. But what about after you ship your applications to the stores? How do you get feedback from your users or crash reports? Well, that's where Xamarin Insights comes in. With just a single line of code in any of your iOS, Android, or Windows applications, you immediately get feedback for managed native crash reporting and any analytics that you want to add. And of course, we have plenty of documentation for learning the entire Xamarin platform. We also have Xamarin University, which is live interactive instructions and classes with Xamarin University instructors. You can go from maybe knowing nothing about mobile development or even C# to a fully Xamarin certified developer. You can get started with Xamarin today at Xamarin.com and downloading and getting started with the free trial. And to learn more about Xamarin Forms, head over to Xamarin.com/forms. And thank you so much. Hi, I'm James Montemagno, Developer Evangelist at Xamarin. And today, we're going to see how you can leverage your C# and XAML skills to build out native iOS, Android, and Windows applications with Xamarin and Xamarin Forms. We're first going to take a look at the Xamarin platform and the Xamarin Forms library for a complete overview. Then we'll dive into just how you can build out those native iOS, Android, and Windows apps with XAML, C#, and MVVM. And of course, I'll show you where to get started. Now, the Xamarin platform is where Xamarin Forms lives. It's where we're building native iOS, Android, and Windows apps, all in Visual Studio, all with C#, and all your favorite .NET libraries. And our approach to mobile development is unique. You build a shared C# backend, all your business logic, models, view models, RESTful service calls, SQL databases, and then build out a unique iOS, Android, and Windows user interface to build out great user experiences. Now, of course, we have great designers for both iOS and Android built right into Visual Studio, and it's never been easier to get started. Simply when you're installing Visual Studio 2015, select Custom Install. Then, on the next screen, select Xamarin. Now, if you already have Visual Studio installed, head over to Xamarin.com/download for our full universal installer. Now, let me introduce you to Xamarin Forms. Xamarin's approach to development is unique, that shared C# backend, and that doesn't change with Xamarin Forms. It's just a brand new library enabling you to build a shared UI codebase all in XAML across iOS, Android, and Windows to share even more code. Now, built right into Xamarin Forms is, of course, 40+ pages, layouts, and controls that you can access from shared code, but it has MVVM in mind. with two-way data binding, a cross-platform navigation system, an animation API that uses the underlying core animation and Android animation systems, a dependency service, and of course a messaging center, all the tools you need to get started with mobile development. There's plenty of pages such as navigation, tabs, and carousels to get you off the ground running, and of course ways to lay out your controls, stack, relative, grids, scroll views, and you can of course nest and bundle this all together. And then there are those controls, sliders, pickers, entries, buttons, anything that you can access from shared code that has an abstraction across iOS, Android, and Windows. It looks a little bit something like this. Let's say I'm creating a login page. I have a stack layout, 2 entries, and a button that's green that has a command binding to the login command. And as we can see on the bottom, we have our iOS, Android, and Windows Phone applications, 100% native, all using the shared XAML codebase. Let's take a look really quick on how to get started with Xamarin and Xamarin Forms to build out native iOS, Android, and Windows apps, all in XAML. Here we are inside of Visual Studio 2015. When I installed Visual Studio, I also installed Xamarin. So once you have Xamarin installed, you can go to File, New Project, and you're going to see some brand new project templates. You'll have Android, iOS, and under Cross-Platform, you'll see our Cross-Platform templates. To get started with Xamarin Forms, simply select Blank App for Xamarin Forms with either a portable class library or shared code project. Now I already have an application set up. It's called My Weather. We're going to go out, get the current weather for whatever city that we're in, and even get a 5-day forecast. So let's go ahead and take a look at the project structure. Here we are inside of Visual Studio in our Solution Explorer. We have our portable class library with our models, views, and view models, MVVM if you will. And then of course our Android, iOS, and Windows application. Now what's nice here is that all the code that we're going to write is inside of our portable class library. When you create a new Xamarin Forms project, some NuGet packages will get downloaded, such as Xamarin Forms itself, and if you want to use maps, there's a Maps NuGet package. I've additionally installed some additional NuGet packages such as Xamarin Insights for crash reporting, JSON.NET, and a few plugins for Xamarin and Windows such as geolocation, settings, and text-to-speech. Let's actually dive into a little bit of code. So it all begins with our weather service, where we're going to query openweathermap.org to actually either get our weather via latitude and longitude, or pass in a city with some units. Additionally, I can go down here and get a full 5-day forecast for a specific city that I have. Now, what are these weather forecast routes and weather route objects that I'm going to be deserializing? Well, what I did here is I went and I took our OpenWeatherMap API call, here it is, went ahead and copied it, and back in Visual Studio I created a whole bunch of weather objects. Now, to bring this in, you can easily say Edit, Paste Special, and that JSON we copied, just go ahead and paste it as classes, and all of the classes will be generated for you automatically. Now, I've done that ahead of time, so here it is, such as coordinates, weather with our main description or icon, temperature, pressure, wind, and clouds. And we'll see that we'll be data binding to some of these objects. And the key of it here is that use Xamarin Forms. We're going to create our views all in XAML, but we need some code in the code behind to actually bind to the user interface. And that's where our weather view model comes in. Let's take a look at the top. Here we're implementing iNotify property change that I'll get back to later. We're using our weather service, and I have a few properties to bind to, such as the current location that I'm going to enter. If I want to use the city, and we're saving these back to our cross-platform settings. Do I want to use imperial or metric, our current temperature, condition, and an isBusy indicator to know if I am doing something on the network. Lastly, what we'll have is a command. And when we command, it's essentially when I click a button to get the weather, it will call this execute get weather command. Well, we can see what I'm doing down here is I have some breakpoints, so we'll remove those. But if I want to use the city, I'll go ahead and pass in the current location to the weather service, and then I do some nice string interpolation to get the forecast, set the temperature and condition, and my user interface will react. If anything goes wrong, I'll notify my users by setting the temp to unable to get weather, and I'll report it back to Xamarin Insights so I can get a little bit of analytics and eventing when something goes wrong. And I can see this warning in my panel. Now all this magic data binding is happening by iNotify property change and implementing a property changed event handler. And we can use our amazing brand new C# 6 features with the Elvis operator and member body functions to simply invoke it whenever I change a property, let our user interface react. So now we actually want to create a little bit of user interface, and that's where our views come in. I have created a forecast view and a weather view. Let's go ahead and take a look at the weather view. It's simply blank. I have a new content page, and this is all XAML with weather and a binding for the busy indicator. So I have a stack layout. I'm going to stack some controls up. So the first thing that I'm going to do is have an entry. And I'm going to say text here is a binding to location that I'm going to enter. Then we'll go ahead and enter a buttons. They're Xamarin Forms controls. And this will simply say get weather. And the command, when it is clicked, will have a binding to the get weather command. There we go. Now we'll actually display some information when our results have come back and been deserialized. So we can say label, and we'll set the text here to a binding of temp to display the temperature. And we'll set that font size pretty big. Let's set it to 25. Additionally, we can go ahead and specify the condition to see if it's cloudy or sunny outside. So a condition, there we go. And the last thing we want to do is create a little activity indicator to let our users know something's happening on the user interface. So let's set the is running, and we'll do a binding here to is busy, so only run it if it's busy. And also, I'll say make it only visible too when something is happening. There we go. Now we have our user interface in place for our weather page, but we also want to display a full 5-day forecast. So how could we accomplish this? Well, I have a forecast view, and inside of here, I have a list view as the main content. And this is going to be bound to a list of items in my forecast. And then I can set a data and item template, such as an image cell that's being bound to each item's display temperature, display date, and display icon. If I go back to my weather object and scroll down a little bit further, we can see here they are. I'm doing some nice date time parsing, string interpolation to get the temperature and the icon to display. Now to set all this up, it all comes down to the app.cs. This is the main entry point of our application that's cross-platform. So here we have our application, and on the bottom we have on start, on sleep, and on resume for some lifecycle events. But I'm going to go ahead and new up my view model, and then I'm going to create a new tabbed page. And the key here to my weather is that I have two views, my weather view and forecast view. I'm setting the binding context to that view model. So when I get the weather, both of the views will react. And then lastly, I'm going to go ahead and set the main page of my entire application to a navigation page so I get a nice title bar, and set the background color and text color as well. Now, of course, I have still in my Solution Explorer an Android, iOS, and Windows application with the same NuGet packages installed. Now, if I need to access some platform-specific code, I can go in here and access 100% of the APIs. But we didn't need to for my weather. Everything here is in our portable class library. I've set the Android application as the startup, and I have any of the emulators or physical devices, and we can just simply start running it. Here we go, the application started, and we can see it right here in screen mirroring. I'll go ahead and hit Get Weather. This will go out, get our temperature. I can slide over to our forecast, and we're good to go. Now let's check out the Windows application. I'll go ahead and set that as my startup. This will be my local machine, and I'll again start it up. No additional code's been written in the Windows application. It just works with Xamarin Forms. Get the weather for Seattle, and we can even browse the forecast. Now what's great, since it's a universal Windows app, is I can go ahead and set the Windows Phone emulator as my startup and start that up. And there we go. We get the same Seattle and Get Weather, and I can browse over to my forecast. Last but not least is iOS. Here it is. I already had it installed, and I'm screen mirroring back over to my iOS iPhone 6, and I get the full forecast available. And there you have it. iOS, Android, and Windows from 100% shared code, all in XAML and C# with Xamarin and Xamarin Forms. We just saw how to get started with Xamarin and Xamarin Forms inside Visual Studio 2015. And that's part of the Xamarin platform. But of course, Xamarin is your complete mobile solution. The Xamarin platform enabling you to design, develop, and integrate all your C# and .NET code to craft those great native iOS and Android and Windows applications, all in C#. But what happens before you ship your application, or even after when you're adding new features? You have great ways of testing with NUnit or XUnit, but you need a way of testing that user interface. And that's where Xamarin UI Test and Xamarin Test Cloud comes in. Build out automated user interface scripts for any of your iOS or Android applications and ship them to our test cloud to run them on over 2,000 unique iOS and Android devices. But of course, what happens after you ship your application to the store? With Xamarin Insights, with just a single line of code, gives you managed and native crash reports in any of your iOS, Android, or Windows applications. We have great resources to get off the ground running started with Xamarin. And of course, we have Xamarin University, our live interactive training with live Xamarin University instructors, or you maybe know nothing about mobile development or just getting started and become a fully Xamarin certified developer. To learn more about Xamarin University and get a free 30-day trial, go to xamarin.com/university. And to get started with Xamarin, just head to xamarin.com. You can get the source and samples at xamarin.com/prebuilt. And of course, follow me at James Montemagno on Twitter and on GitHub. And thank you so much for watching. Hi, I'm James Montemagno, Developer Evangelist at Xamarin. And today I'm going to show you how to leverage your C# and .NET skills to build out beautiful cross-platform, native iOS, Android, and Windows apps in C# with Xamarin, and create great cloud-connected experiences with Azure. Now I'm going to take you through the entire Xamarin platform, start to finish, and show you how to build out those great apps inside of Visual Studio, and then connect them up to the cloud with Azure. And of course, I'll show you right where to get started. Now we're going to focus on the Xamarin platform, designing, integrating, and deploying our iOS, Android, and Windows apps written fully in C# with Xamarin. And our approach to mobile development is extremely unique. Build a shared C# backend for all of your applications. Your models, view models, RESTful service calls, SQL databases, Azure calls, all shared across all your applications. Then we give you the tools to build out a great native iOS, Android, and Windows user interface. 100% native with 100% API access. If you're wondering how that looks, imagine today in the Windows world. You just have amazing .NET libraries that we know and love. Here's just a few of them: System Link, XML, Net. When you want to go to UWP or any other Windows platform, you download an SDK, you get some new APIs to mess around with. You can think of it the same when you go to iOS and Android with Xamarin. You get everything you know and love about .NET, but you have 100% API coverage for every API in iOS and Android. And create these great C# bindings around everything like MapKit and UIKit, and give you C# features such as async await, lambdas, link support. So everything that you know and love of C#, but accessing native iOS and of course Android APIs. Now it's never been easier to get started with Xamarin. When you install Visual Studio 2015, simply select Custom, and then on the next screen, select Xamarin. You're good to go. Now if you've already installed Visual Studio, simply go to xamarin.com/download for our full universal installer. Now when you do that, you're going to have access to our great iOS and Android designers built right into Visual Studio to design and then deploy your applications. Let's take a look at getting started with Xamarin inside of Visual Studio. Here we are inside of Visual Studio 2015. Now I already have Xamarin installed, and when you install Xamarin, you'll get some new project templates when I go to File, New Project. Here we'll see some new Android templates, iOS, and cross-platform. Now I've already created a blank application, and you can create one with either a portable class library or shared code project. Now the application I'm building is called Coffee Filter. It's a cross-platform application that finds the closest coffee locations to me. And if you know me, I love coffee. So let me just go ahead and show it to you really quick. Here it is on both iOS and Android. Here I can flip through all of the closest coffee locations to me. When I find one that I like, maybe such as Regent, I can go ahead and tap on it and navigate to some more details, including some nice parallaxing, get some reviews, photos, and even if I want, get a nice panorama view. I can do the same exact thing over on iOS. Now let's see how this application was actually built. So over here inside of our Solution Explorer, I have my Coffee Filter solution with Android, iOS, and Apple Watch application. some UI tests to actually test my user interface and test those on the Xamarin Test Cloud, a Windows application, and my shared code. Now we'll focus on the shared code, and this is where my models and view models live. Now the first thing that I've done here is actually gone in and installed a bunch of NuGet packages into my iOS, Android, and Windows app, including some Google services, HTTP clients, JSON.NET, and some cross-platform plugins such as connectivity, external maps, and our geolocator to get our cross-platform geolocation from a single line of code. So let's look at that. So here we are back into our shared code. I have my models and my view models, and here's my coffee filter view model for that main page. I have a few query URLs to actually query the Places API. Then I have a position and some places that I can data bind to. I can calculate my distance to the place by passing in a few parameters, navigate to a shop externally when I want to navigate and get directions, simple from an API that'll launch Bing Maps or Google Maps or Apple Maps. Here we can use some member body expressions to get our connectivity, and of course, we can get our location with crossgeolocator.current.getPosition. That'll give us our latitude and longitude. And of course, we'll finally use HTTP client and JSON.NET to query all of those places with a simple API call. Then we'll read it back and use our Elvis operator to do some null checking along the way. Then we have to build a little bit of user interface for our code behind. First, let's look at the iOS project. And under Views, we have a bunch of code behind for our views and our main storyboard. This is a high-level overview of our entire application. We can see from tabs to details to our actual scroll views for our maps. I also have, like I noted, an Apple Watch application that happens to have another storyboard file, but this time a little bit more minimal, just for our few screens that we have when running on the watch. And finally, our Android application. Under Resources, we'll find all of our drawable image assets and layouts, such as the fragment that we saw to put the star rating and the distance. We can look at our code behind here, which is our Android XML. And of course, we can design layout, portrait, and actually test out our grid lines to make sure we're following the great material design guidelines from Google. Now, let's go ahead and look at the application one more time. Here it is, a beautiful cross-platform application with a shared C# code behind built with Xamarin. Now we just saw building those great native iOS, Android, and Windows apps in Visual Studio with Xamarin, but what about creating a cloud-connected experience? That's where Azure Mobile Apps comes in. On the one side, you have your iOS, Android, and Windows applications, and you install the Xamarin and Windows SDKs. This gives you a nice REST API that's exposed to access things like any of your SQL databases, user authentication with Facebook, Google, or Azure Active Directory, and push notifications. And the great part here with Azure Mobile Apps is you get full online and offline synchronization, handled for you automatically. And then you have a full access to your own custom backend code, so you can customize and modify anything that you want. And it's super simple to get started. Simply download the NuGet packages and create your mobile service client. Then, to create some tables, all you got to do is create a SQLite store, define a table, and create it. Now, when we want to add or remove any items, simply to get all my stores per se asynchronously, pull asynchronously. Then, to add a store, insert it, pull the current version, and synchronize. Let's just see how easy it is to get started with Azure Mobile Apps and Xamarin to create great cloud-connected experiences. Here we are inside of the Azure portal. Now I'm creating an application called My Shop, one of our pre-built applications, enabling any store to create an application for themselves so their users and their customers can browse locations and leave feedback. So it all starts here inside the Azure portal. I've created a brand new mobile app called My Shop Demo, and we can see in real time are all the requests coming into the application. Now, once you have this created, simply click Add Client. You'll see Xamarin, Xamarin iOS, and Xamarin Forms. It'll show you how to download Visual Studio, Xamarin, and get off running with the server and the project. Now I've already done that, so I'm here inside of Visual Studio 2015. And what we'll see is a full cross-platform application called My Shop. I have all of my code inside my portable class library with my models, view models, and views, and then my Android, iOS, and Windows application. Let's take a look at the Azure Data Store. This is using Azure mobile apps to create a mobile service client and create a brand new store table and feedback. Let's look at the store really quick. And here we can see some properties, version numbers, name, location, street address, and even images to display. Now I want to go ahead and create my tables. What's nice about this is using a SQLite store for online-offline synchronization. I simply create my two synchronization tables for store table and feedback. Then I have a simple way of simply adding some feedback by inserting it, synchronizing, and returning the current feedback, getting a list of feedbacks, or even deleting them. All the calls are really simple. Simply just grab the table, call delete, call insert, or call get. That's all it is. So here we can get all of our stores by first synchronizing and then enumerating over all of our stores in the table. If I drop down into the stores view model, we can see where I'm getting that. Let's go ahead and go down to our get stores command, where I'm simply going to go ahead and clear all my stores. From that data store, get all the stores asynchronously and add them to my observable collection. Additionally, I sort all of them using our nice link syntax. Now let's take a look at the application. I'm going to go ahead and bring up our iOS, Android, and Windows application. I can browse all of the locations in the application. Here we go. And we see they have nice headers, titles. I'll browse through. Here's our Argentina office. Then I can call and even navigate to, and I even get a nice map view of the location. Now what's also really nice is that I can come in and have my customers leave feedback. I can select the store and say, awesome, and submit that back to my Azure backend. Now, I want to actually find out and see when feedback is coming in. Now, I could come into my Cloud Explorer here, and I'll pin this over there. I can browse all of my SQL databases and mobile apps. And here's my MyShop demo database. And if I go over to my SQL Explorer, I can browse not only my database, but also my tables inside of it, and of course, view the data. Better yet, what if I had an application as the store owner to grab this data? We can leverage our shared backend and our portable class library to create an admin application for iOS and Android and even Windows. And I can just add a little bit more logic and customization to build out and pull this data in and manage it as a manager. So now if I come back over to my iOS and Android application and load up the administration application on Android, I could manage all of my locations easily. Here they are, and instead of going to details, I actually have an editing view. I could also come back and view all of that feedback. There it is. There's the latest. Awesome that I just submitted. Perfect. Now what's great is that you can get started by just adding a mobile app, but to try it yourself, you can head over to tryappservice.azure.com. This will bring you to a nice landing page, and when you scroll down, you can select a mobile app, hit next, select one of the Xamarin applications, such as our CRM application, and create it. Log in with one of your accounts. This will create your entire backend and give you the entire project already pre-done that you can try out. Here it is. Simply download Xamarin iOS or Android, and you're good to go. And there it is, creating a beautiful cross-platform iOS, Android, and Windows application, all connected to Azure. Now we just saw a great whirlwind tour of the Xamarin platform, crafting iOS, Android, and Windows apps in C# and .NET, and taking it to the cloud with Azure. Now with Xamarin, you're always up to date. We've been shipping great support and same-day support for iOS since iOS 5, including the latest iOS 9 and 9.1. And we have great support for the new emerging devices that are out there, because it's not just about phones and tablets anymore. We have support for Apple Watch, the Amazon Fire devices, Android Wear, TV Auto, and even Google Glass. So now you can take your C# and .NET code and run on over 2.6 billion devices around the world. Now we focus heavily on the Xamarin platform, designing, developing, and integrating our C# and .NET code, but Xamarin is your complete mobile solution. And it's not just about building and designing and developing, it's also about the testability. And of course, we can write business unit tests with NUnit or XUnit, but what about our user interface? How does it scale and react across the thousands upon thousands of devices? And that's where Xamarin UI Test and Xamarin Test Cloud comes in, enabling you to craft automated user interface scripts and run them on over 2,000 unique devices in our Xamarin Test Cloud. Of course, what happens after you ship your app to the App Store? How do you get your analytics and crashes back to you so you can analyze and improve your app? Well, that's where Xamarin Insights come in. With a single line of code, you get all of your managed and native crash reports for iOS, Android, and all the Windows platforms. We have great resources to get you started, and we also have Xamarin University, live interactive training where you can become a Xamarin certified developer. You can get a full access to Xamarin University with a free 30-day trial at xamarin.com/university. And to learn more about everything you've seen here, just simply go to xamarin.com. Or to try Azure App Service, go to tryappservice.azure.com. And be sure to follow me on Twitter and GitHub at James Montemagno. Thanks.
Hey, I'm Ankit Asthana, a program manager for the Visual C++ team. In this talk, I'm going to provide an overview on what's new with Visual C++ Cross-Platform Mobile in Update 1. I will follow this up with a few demos and then wrap it up by providing you a link to resources where you can follow us to get started. While our main scenario is still targeted for cross-platform C++ applications, a major request we've heard is to provide support for Java debugging and basic code editing when developing Android applications. Update 1 introduces a Java language and debugging experience for Android targeting. In addition to this, with Update 1, Android applications will build faster as a result of the support introduced for parallel compilation, similar to the /np feature for the Windows platform. Newer flagship Android and iOS devices are ARM64 and x64 respectively. As a result, with Update 1, we are introducing support for x64 and ARM64 targeting. Android and iOS developers will now be able to build and debug for these platforms as well. CMake is a popular cross-platform build system generator, and Update 1 also provides a Visual C++ Android project generator for all the CMake users out there. This will allow an easier experience for developers to move their code to Visual Studio. For developers currently using Eclipse for Android development, a converter has also been introduced which will allow easy conversion of Eclipse Android projects into Visual Studio Android projects. In addition to all these new features for the Android platform, we've also revamped our iOS experience, which provides a better out-of-the-box support for iOS development. And now also, it allows for auto-discovery for debug targets and iOS provisioning profiles. Lastly, on the Windows front, a new Clang-based compiler with the Microsoft Code Generation C2 compiler has been introduced for building your cross-platform C++ code across applications. Next, I'm going to go into some demos. Welcome to this demo. As a part of this demo, I will be showing you some of the new features we've added as a part of the Visual C++ mobile experience in Update 1. The first thing I want to show you is the Android Project Importer. The Android Project Importer allows you to import your existing Eclipse projects into Visual Studio easily. You can point to a workspace or project and then click Finish. Next, I want to show you guys the Java language, service, and debugging experience. For doing so, I'm going to bring up the More Teapots application. More Teapots is a JNI application, which means it has both Java and C++ code. Let's now take a look at the native activity project by looking at the project properties. The native activity project builds all your C++ source code and is currently getting built as a dynamic shared library or an SO file. We're currently targeting Android API level 19, and this C++ source code, which is being built as a dynamic shared library, is then used to build the end-to-end Android application package file or the APK file using the AND-build system. The packaging project is responsible for invoking the AND-build system, and it also contains all the Java source, assets, and artifacts required for building your Android application package file. For demoing the Java language service experience, I'm going to bring up the More Teapots application.java source file. Let's go ahead and add a log message in the onCreate function for this application. For doing so, I'm going to import the Android util log package. Notice that as I'm importing this Android util log package, the autocompletion helps me to find this package. Additionally, also notice the squiggle that's appearing currently in this source file. The reason for the squiggle to appear is because Java Language Intelligence is telling us that this import is currently not used. Let's now go ahead and add a log message. Notice how adding this log message, which uses the Android util log package, now results in the squiggle being removed and IntelliSense is happy. This is a preview experience that we're offering today for Java Language Service Experience, and it's especially targeted for Android users. But some of the other features that you guys are used to when editing code in Visual Studio also work for Java. For example, I can go ahead and say go to definition on this AI type, which currently takes me to the source line where this was defined. Next, I want to show you guys a debugging experience. For doing so, I'm going to set up a couple of breakpoints. Notice how the debugger drop-down menu is currently pointing to an ARM64 device. With Update 1, we've also added support for ARM64 and x64. In this particular case, More Teapots is an application which is being built for the ARM32 platform, but is being deployed or targeted to for an ARM64 device. This is a fairly common scenario, and we're happy to provide this experience in Update 1. Next, I'm going to hit Deploy, which will basically build my application and then deploy it to the device. Notice how the APK was built successfully. This will now initiate the debugging experience for Java. Notice the breakpoint that we set was hit, and the locals window, the call stack, the watch window just work automatically. We also provide support for some of the other debugging features. For example, I can look at the threads window, conditional breakpoints, and so on. Using this experience, developers can easily develop Java-based Android applications as well, now using Visual Studio with Update 1. I hope you guys enjoyed the demo. Thank you for watching this video. You can follow us on vs.com and VC Blog to keep up to date with our latest offerings in the cross-platform mobile space.